Hello friends, we are going to see now closure properties of regular languages. You are aware of the finite automata, regular expressions, and also languages which are regular and non-regular. Now what is this closure property? The closure property is nothing but some kind of operation we are going to apply over the languages. So which languages you are going to apply, which is mainly for regular languages, but also we are going to learn the finite and infinite languages along with regular languages. So without delay, let's begin the closure properties of regular languages. Okay, in a minute. So what did you learn in closure, regular expressions and finite automata? In regular expressions, we have learned how to write a regular expression. If somebody gives you regular expression, you should know what is the language represented or denoted by the given expression. And in finite automata, we have learned deterministic and non-deterministic, both the machines. We have designed various machines for given regular languages. Now in regulars and non-regulars, we have learned how to identify the languages, whether the language is regular or not. Okay, there we have seen the finite languages and infinite languages. In the infinite languages, which are regular and non-regular, both we have seen. Now let's come to the point, what is a closure property? What is closure property? Okay, the closure property is nothing but an operation. The operation could be possible which is either unary or binary. It could be any array, right? If it is unary, you will be having the one operand, which is operand nothing but a language here. So you will be having one language, over that you are going to apply the unary operation. And sometimes you may apply the binary operation, for which you require two languages. And you may take any array, let's say k array. Example, in unary you will be seeing like examples, complement or a reversal operation over the languages or over the language, and maybe sometimes subset operation. There are closure properties you are going to look into. And binary operation, you will start with like basic union, intersection, maybe sometimes you will see concatenation, or you will see set difference or language difference. When it comes to many number of operands, more than two, then we will go for k-array. Like you may have finite union. That union you will apply multiple times. That means you will be having many operands. It means many languages, but when finite union is applied, you will be having the k inputs to the operation. Similarly, finite intersection, finite difference, finite concatenation, and so on. It could be possible even infinite operation. Practically may not be possible, but theoretically we will be talking about infinite union, infinite intersection, and so on. So this is nothing but the closure properties, where we can apply for finite languages, infinite languages. We can apply for different domains like regular languages, context-free languages, but we are in the basics. It's just lecture 3. So here we are going to talk about, we are going to learn for finite languages, infinite languages, mainly for regular languages. Okay, what is closure property? So closure property, here we will be having a domain. This domain is going to have your required languages. Here, if I am talking about finite languages, here you will be having finite languages. How many finite languages will be there for the given sigma? Could be infinite, right? It will be infinite. And this domain could be set of infinite languages, or this domain could be set of regular languages. It all depends on what is your requirement. Your domain could be regular but infinite languages. It could be every language you want to be infinite, you want to say infinite and it has to be regular, then you can fix the domain. Fix the domain and apply these operations and look at, is the result belongs to domain or outside the domain. If the result belongs to domain, then that operation called as closed. And if it does not belongs to this domain, after applying the operation, if the result goes outside the domain, you take the input from the domain only, but output, if it is not going to the domain, that operation is not closed. So we are going to talk about two words, closed and not closed. Closed and not closed. What is closed? operation is closed or not for this domain. Operation, is it not closed for this domain? So this is how you are going to learn. When it is closed, what do? You take the languages from the domain, apply the operation. If the result inside the domain, that operation is called as a closed. Let's take complement. Assume this language is this domain is regular languages. So here how many regular languages will be there? Infinite regular languages, like starting with A, ending with B, containing A, two-length strings. So many languages are there here. All these are languages. Infinite languages are there. You want to apply this complement operation. You want to know whether it is closed for this domain or not. What do? You take the language and apply the complement. Observe the result. Is it always inside the domain? Because your input might change. Input need not be particular language. It could be anyone from this domain. So if always in the domain, you must have a proof, algorithm. So is there any algorithm that says that you take the language from the domain and the result inside the domain? Then in that case, this complement is closed. If you get a scenario or if you get a situation, among this, you found one language. After applying the complement, it goes outside the domain. The result goes outside the domain. It's enough to say this operation is not closed for the domain. So you want to say closed, you want to say this operation is closed, then all the time the result has to be inside the domain, because input from the domain, output has to be inside the domain. And if you want to say it is not closed, input is definitely from the domain, but output, at least one case you see that it goes outside the domain. Just find the example. You don't need algorithm for that. Just proof by example. At least one language among this, all the languages, you found that complement of any language goes outside the domain. It's enough to say not closed. So closed represent always the result inside the domain. Not closed means at least one time. That means you found at least one example. Here proof require an algorithm. For the closed, for not closed, proof required just an example, because to say not closed, you need to find one example which goes outside the domain after applying the operation. So we are going to see this. When we say closed, believe me that you will have an algorithm. Not closed, you will be having an example. So closed requires algorithm to prove it for all the regular languages, because we can't check every regular language whether it is inside the domain after applying the operation, because there are infinite languages, infinite regular languages. You can't do that. So you read algorithm. This algorithm guarantees you give me any input, the result, any input from this domain, result always in this domain. It will prove it. How? We are going to see. And not closed, you just require example which goes outside the domain after applying the operation. Okay, without wasting the time, these are just basics what I'm talking about. In case if you are not having awareness here, you must stop here. You should learn about what is closed, what is not closed, and how to how to apply these operations over the languages. You should know the meaning of each operation. Then we can learn complement of a regular. Is it regular or not? Complement of finite. Is it finite or not? Complement of infinite. Is it infinite or not? So these things we can learn very easily. I hope you should take consideration of these definitions before learning the closure properties. Okay. Let's start with the first point. Let L1 and L2 be two finite languages. L1 and L2 both are finite languages over any sigma. I have taken just for an example A comma B, but you could take any sigma. Then what is L1 union L2? What is L1 union L2? It indirectly says that finite union finite. So even whenever I take the finite language union another finite language, you tell me the result will it be. I'm just talking about one direction. Remember, you find only if the words are different from if then. See here, if then kind of statement. Now if L1 is finite and L2 is finite, what is L1 union L2? Okay, is it finite, is it regular, or is it infinite, or not? This three could be any other answer. So what is it? Finite union finite. Of course you need just mathematical knowledge for this. The theory of computation do not require to answer this question, right? Finite union finite is always finite without any doubt. We slowly move into regulars, but before that, you should know about the concept of union, how we apply for finite union too. And that's not enough. It is finite, we know it, but in the exam, it could be MSQ type. Finite is no doubt, every finite is regular. So this is also true statement. If they ask choose strict answer, then choose finite. If it is MSQ type, if they don't say choose strict answer, if they don't say, then choose both of them, finite and regular. Okay, depends on the question type, you need to follow the options. Here I did not mention other than the statement, you must answer this A and B, and this question definitely MSQ type. More than one option could be possible as a correct. Fine. It's impossible to be infinite, so definitely we will not choose the infinite. Okay, I hope you are aware of this concept. Finite union finite is always finite. Okay, let's go to the next example. We will come up with a lot of various examples. Please, this lecture is going to help you to solve many gate questions. It means even though we are learning very basic operations, but that are mostly asked in the exam, like union, intersection, set difference, concatenation, complement, reversal, these things asked multiple times in the exam so far. Let's move to the infinite languages. I have taken two infinite languages, I applied the union. So what could be the result? I have infinite set, that is L1, and I did the union with another infinite set, which may be same or different infinite, do not worry about it. What will be the result? Is it always infinite? Is there any situation that you will get finite? Okay, so it's very important. These two are completely opposite statements. If the result is finite, it never be infinite. If the result is infinite, obviously never be finite. So there is no doubt about it. Finite and infinite both are possible at the same time. Okay, different situations may be possible, but at the same time both cannot be the same, both cannot be the answer. Infinite union infinite, what is an answer? Infinite. Result definitely infinite set. And you know the fact, if one of the language is infinite, result definitely infinite. You don't need to be both are infinite, but in the given question both are infinite, so you are so safe, result is infinite. So let me talk about few points. Finite, I know one of the languages finite. I'm just giving a note. In future you may see this kind of questions in the exam. Finite set union some language L is unknown, arbitrary, it could be any. I have not mentioned about L, some language which is not known right now, but finite union L, what would be the answer? Can you guarantee finite? No. So what is important here? It depends on L. The result depends on L. Why? If L is finite, the result is finite. If L is infinite, the result is infinite. So whatever L says, the result has to be like finite union L. Then if L is a finite, the result is finite. If L is infinite, result is infinite. That's what I have written. That's why I have written it depends on what type of L it is. Okay, it need not be exactly like L, but after union language may change. But if L is the finite, result is finite. It could be different finite set, but result is finite if L is the finite. So it depends on L. Let's talk about the second point. Infinite union some arbitrary language L. Here L is unknown. Note that point. L is arbitrary language. Infinite union any language in the world, will be the result always infinite? Yes. So this was a GATE previous year question. They have given n number of languages. We know that one of the given languages or one of the given sets is infinite. What is the result if we apply union of all the languages? Definitely it has to be infinite. So here we don't worry about L. L may be finite or infinite. The result is already decided, it is infinite. So these points are really important for us in the exam. In the exam, everything might be given then answer could be very easy. But sometimes when you are applying the union, one operand might be provided to you, other operand is arbitrary, then the result you have to think about whole universe, how it is gonna be. Fine. Take two examples. If I say it depends on L, why depends on L, take L is a finite and take L is infinite. If you see the answer is same, then you can do that. But answer is not same. It depends on always L. If L is a finite, result is finite. If L is infinite, result is infinite. So result is changing depending on the L. This is how you should think about. Fine. Now what is the result? If it is infinite set, then we will choose infinite. And definitely it is not finite, we got to know. But talk about regular. Is it regular? Think about infinite union infinite. Is it regular always? No. Sometimes possible to be regular, sometimes not regular. So only it is sometimes, so you should never choose this. We choose the option regular only when all the time it is regular. Got my point? Need not be regular, may be regular, may be non-regular. That statements are right. The regular is wrong statement because only sometimes regular. Under which circumstances it could be regular? You can see that. Suppose I'm taking infinite union infinite. Suppose I take A star union A star. Because infinite union infinite, it is again infinite. But what do you get here? Regular. It's not always, right? It's not always. If I take A power n, B power n, it is infinite. Very simple infinite. No need to be both are same. Only why I am taking here is just to give a good impression on the result. Result will be very easy to judge for you. A power n, B power n. See, infinite union infinite, and result may be non-regular. Sometimes regular, sometimes non-regular. So infinite union infinite, we know infinite, but need not be regular. If you see one of the option is need not be regular, then that is the right answer. Right now, regular is wrong option. Fine. So in the exam, you should aware of it. If they give one of the option need not be regular, you should choose it. Okay. Let's move to the next question. L1 and L2 are both are regular languages over particular sigma. Then what is this? L1, this is called as a closure property. So we have seen two closure properties so far. Union for finite languages, union for infinite languages. Now, is it closed? Union was closed for finite because the result is always finite. Union was closed for infinite, the result, that's why it is closed. So in the previous two examples, union was closed for the finite languages as well as for infinite languages. Now we are going to see our important topic, regular languages. Now we have the domain where we have all the regular languages. Now you took two languages and applied the union. Is that result always regular or not? If it is always regular, then we can say that union is closed. But union is closed, we will choose that later. But right now, regular, union, regular. This is your question, right? Regular set, one is regular language, other is also regular language. Now you tell me, is it regular? So how to prove it? Yes, there are algorithms to prove it. Because regular set, you can write a regular expression, another regular set, you can write another regular expression. Then to do the union, just put a plus, you will get a new regular expression. You know that when you have a regular expression, you have to believe whatever it generates, it has to be regular. Fine. Another way to prove it, you can construct a finite automata for regular set or L1. For L2 also you can construct another finite automata. So we have a composition algorithm, a union algorithm to combine both the DFAs or both the finite automatas to get another finite automata. Okay. So there are many ways to prove why regular union regular is always regular without any doubt. So always word is implicit. Just say that regular, but we know it is always regular like previous examples. It means union is closed. Union operation is closed for regular languages. Not only for regular languages, even for finite languages, this union was closed. Okay, fine. This is a very interesting point. Union is closed for finite languages, union is closed for infinite languages, union is closed for regular languages. Correct? Now we have many interesting points which are going to come in the next coming slides. How do you think the possible or predictable gate questions? Regular union finite, regular union infinite, or what else you will have? Non-regular union non-regular. So these are the things we are going to look at. Anyhow, let's conclude the options. Finite may or may not, because regular union regular result may be finite or infinite. That depends on what regulars you take. So this option is wrong. Regular definitely correct. Infinite really not always. Regular union regular, the result may be infinite or may be finite. That's why we don't choose this two. What if you want to choose the finite word in the statements, you should say need not be finite, need not be infinite. That are the correct options in case if you have need not be infinite option in the gate. Right now only the regular is suitable. Fine. In case if you want to learn about the reason behind this, you should learn about the proofs, because I told whenever it is closed you should know the algorithm. Why we say the result is always regular? Because we have algorithm. Like for this regular set you can design finite automata 1, and for this regular set you can design finite automata 2, and with this you can do the Cartesian product to design another finite automata. You get this will accept. Of course we have a new finite automata after composition, and this is going to accept union of two regulars if you choose the final states as per the union condition, because intersection union you can do the Cartesian or composition of two finite automata. Fine. So this is how you prove using algorithm. Next, a very interesting question, and mostly this kind of questions may not be discussed in the textbooks or videos, but these are going to appear in the exams. In the exam, basically when you sit, they are going to test your knowledge. You learn something from books, and are you going to apply them properly or not? So this kind of question is one where it is going to test your knowledge. So what knowledge it is? There are two languages which are non-regulars, and when you do the union, non-regulars union non-regular, non-regular union non-regular, what could be the result? As you know, we will never learn like non-regular language as a topic, but we'll learn regular language, because the regular language you have a proofs, but non-regulars we can't talk about that, because non-regular could be beyond your imagination. You did not learn properly non-regular yet. Getting my point? Because we are still in regular languages, you are looking into regular expressions, finite automata, and the maybe regular grammars. These things are only focusing on, which all focuses on regular languages. Now come to the point again, non-regular. What is this? A non or not, both are same. Non-regular set union another non-regular set. What is the result? You have seen so many non-regular languages while identifying the regular languages. Now, non-regular union non-regular. Is it always non-regular? Never say blindly non-regular without having analysis. See, it could be possible regular or non-regular. You should think about two directions. Is there any example that you will get regular? Is there any example that you will get non-regular? If you get two examples for two reasons or two different answers, then you have to say need not be regular. Let's look at. I'll just take two examples. One scenario, I'll take non-regular like a power n, p power n. I may take another one is also same. Then result is what? Non-regular. Yes or no? Again you will get a power n, b power n, right? That's okay. You got an example for non-regular. But is there any example which is going to be union of two non-regulars is regular? This is what very important. A power n, b power n is what? Non-regular. What about complement of this? Is also non-regular. It's a very important point. A power n, b power n is regular. Its complement is also regular, so non-regular. Both are non-regular. A power n, b power n is non-regular. Its complement is also non-regular. Complement in the sense from the sigma star delete a power n, b power n strings. And when you do the union, you will get sigma star. That is regular. See that even though you did the union of two non-regular languages, you may get regular. This is what I am talking about. Do not just read the sentence or words. Look at the internal meaning of the non-regular. There are infinite examples in the world, and choose the example properly. There could be possible result is regular. It's very easy to find out non-regular example. Here the problem is, do you have any regular example after union of two non-regulars? Yes, I have given clearly an example. A non-regular union non-regular, we can get regular. Okay, so let's point out this answer is need not be regular. My domain is non-regular languages. Here only non-regular languages are there in my domain. When I pick two non-regulars, I apply the union, the result may go outside the domain. Outside the domain, here you have regulars. Okay, so now point is this union closed for non-regulars? No, because sometimes the result may be outside the domain. So here you can say very clearly, note this union operation is not closed for which languages? Non-regular languages. If the domain has non-regulars, this union is not closed. Okay, now options, finite we can't choose it, and also remember regular we can't choose it, but infinite. Now think about, if the language is non-regular, every finite is regular, right? Now can you conclude that every non-regular has to be some infinite? May not be every infinite. This infinite union infinite over the particular sigma, definitely it's going to be infinite. See how we are concluding it. Here there is no answer need not be regular, but infinite is right answer. Why? This non-regular language never be finite, but not every infinite, but some infinite, no doubt. Some infinite language, it is also some infinite language. Infinite union infinite could satisfy infinite. So here see how beautifully this option has options are designed for this question. And definitely if you are not aware of this, you might ignore this infinite too. Okay, so definitely language is infinite, but answer may be regular or may be non-regular. It depends on the given two non-regular languages. And also remember a note, every finite is regular. We know that every finite is regular. Let me note that point. Over sigma, over any sigma that you take, L over sigma, language over sigma. Okay, first point is, we know every finite set, every finite language is regular. That's good point. We already studied in identifying regular languages. Second point, every non-regular that you take over sigma should be infinite. But do not use the converse statements like every regular don't say finite, every infinite don't say non-regular. So these statements are wrong. Like third one, if I say regular language need not be finite. Regular set or language need not be finite. It may be finite or it may not be. Similar way, non-regular, every infinite that I am talking about, infinite set need not be. We know that in some of the infinite sets like a star, a plus b whole star, they are infinite but they are also regular. Infinite set need not be non-regular. These four statements are very important for you. Here the first two statements are one direction, that means finite is regular but regular need not be finite. Here non-regular is infinite but infinite need not be non-regular. So keep this in mind in the exam. So choose the statements properly and correctly. I hope you got a clarity how to do the union of two non-regulars. two non-regulars, union may be non-regular or may be regular. That's why union operation is not closed for non-regular languages, but union was closed for finite languages, infinite languages, as well as regular languages. Okay. So let me give a conclusion here. When somebody talking about union, anybody talking about union, you should know about finite, union, finite. Okay, some finite language ij. Okay, the result is always some finite language k, or regular language like ri, some regular language union, some regular language j. You will get some regular language k. Don't worry about ijk, it just represents some regular. And infinite languages I union I. So the capital I represent for infinite here. So remember that. And F represents here finite set. R represent regular set. Some regular language. I represent some infinite language. The result is infinite. But when I take NR, NR represent here, let's say non-regular. Okay, you just name that NR means non-regular language. Non-regular set. Some NR union, some NR result is very difficult to say, but definitely it is infinite. But here result is question mark. It need not be NR. Remaining C, finite union, finite, finite, or regular union, regular, regular, infinite union, infinite is infinite, but non-regular union, non-regular need not be NR back. Need not be NR. That is non-regular. That's why union is closed for these three domains. For finite languages, for regular languages, for infinite languages, this union is closed, and for non-regular languages, this union is not closed. Okay, if you are going to make a table, then for finite languages, finite sets domain, again infinite sets, regular sets, non-regular sets, the union is closed. Tick means, remember, closed. Cross mark represents not closed. So now these three domains, the union operation is closed, but non-regular sets, it is not closed. Okay, so still there is a lot to learn about union. Right, I have just explained a very simple examples, and they are very important for the exam. And let's go for more in detail about the union. If L1 is finite and L2 is infinite, then what is the result? So one language is given as a finite, another language is given as infinite. Can you conclude it quickly? The result is what? Always infinite. Any idea why did I say the infinite? Because any one of the languages infinite, result is infinite. Because infinite set is dominator for the union indirectly here. Okay, infinite set union with any language, assume this is any language, result is always infinite. But we know here it is finite. Finite union infinite is infinite. Okay, now options. Finite will be wrong. It's impossible to be finite, so you can't. Regular may be regular, because this infinite is unknown, right? It may be regular, it may not be regular, depends on what is given here. Sorry, in the world, in the infinite sets, you have two types again, regulars and non-regulars. Here, if it is regular, then result will be regular. If it is non-regular, then result will be non-regular. So you can't answer regular right now. Infinite is the right answer. Clear? L1 is finite and L2 is regular. Very, very interesting question for you now. Think about, try to answer it, because I am going in detail and clearly So in meanwhile, if you get an idea for this question, answer it and wait for my explanation. So cross check the way you thought and the way I explained, is it matching or not? Finite set union regular set. What is the answer? Can I say finite? You can't, because regular could be infinite. Regular set might be infinite language. You do not know, right? If the regular is finite, okay, it's fine. Result will be finite, but regular is not guaranteed always finite. Finite union regular. Can I say regular? Why? If it is regular, why? Because the finite you can design finite automata, and regular language you already have a finite automata. So these two finite automata can be combined to get a finite automata back. It's always guaranteed result is regular, because we can design finite automata, or we can write a regular expression for the result. Now finite may or may not be, so we don't choose it. Regular always. Infinite not guaranteed, may or may not, sometimes infinite, sometimes finite. That's why we don't choose this two. So finite union regular is always regular language. So whenever you are having any doubt, use algorithms proofs to understand this concept. If you take an examples are limited, right? But it is always regular. Taking examples will not help you, but it will help you to understand the operation, but not understanding the result of the operation. Remember, when it is always regular, examples will not help you. When it is sometimes regular, sometimes non-regular, then one example why regular, one example why non-regular, that time it could help. So understand why we require to go for the proof or algorithm to understand the result is regular. Let's move. Infinite union regular. Again, easy question for you. Infinite set, the L1 is infinite set and L2 is regular set. What is the result? And do not say blindly regular, because this infinite not guaranteed regular, right? May be regular, may not be regular. In that case, it may be regular. Suppose if it is regular union regular, always regular. But if it is non-regular union regular, that is also another interesting question. We will see that too soon. Answer could be anything in that case. Now regularity you can't understand, you can't answer it uniquely, but infinite set union anything in the world, can I say it is infinite set? This property we are already aware of it. We know clearly it is infinite, but what we don't know is whether it is it regular or not. Maybe regular sometimes, maybe non-regular, depends on what infinite you are taking. Okay, what infinite you are taking. Now finite is definitely wrong. Regular you can't guarantee, infinite you can choose. Okay, you if you want to talk about the regular property or regular language, you should say need not be regular. That is the appropriate answer. Okay, let me ask one question here. Sorry for interrupting, but still it will help you a lot. Regular union non-regular. So can you think about what's happening here? Regular union non-regular. We know regular union regular is regular, non-regular union non-regular could be anything. Now regular union non-regular. So to conclude these answers, because here you can't prove it, these two are not from the same domain, right? They are having different properties. Now this regular language doing the union with the non-regular, is it possible one case regular? Let's try with examples. I'm trying regular. Let's take sigma star, union with any non-regular you take. Let's say a power n, b power n, result is sigma star. That means somebody can say it is regular. And one case we got a regular, but not always, right? It could be possible the regular can be empty language, union a power n, b power n, then result is a power n, b power n. So I hope you got a clarity what I'm trying to say. Regular union non-regular, we are very clear It need not be regular, need not be non-regular, right? But is it possible to be infinite always? Because every non-regular we know over the sigma is infinite. Infinite union anything is infinite. That's concluded. The best answer is here. This is need not be non-regular. As we are talking about regular property, need not be regular is correct. Need not be non-regular is also correct. But it's very clear the result is gonna be infinite set. Result is gonna be infinite set. In case if you want to talk about, it is infinite set, some infinite set. This is how you can combine the union. You can combine the two languages which are from different domains. In the exam, this kind of questions are very important to apply the knowledge on the regular as well as non-regular, combining them. Let's move. L1 union L2 is finite. Here we have the assumption that both L1 and L2 has to be finite. So it's okay here, but not all the time. It's okay here because what is given to you, if L1 union L2 is finite, this is given to you. What is not given, L1 and L2 are not given to you. That means you should think about, is L1 possible to be finite? Is L1 possible to be infinite? You should think about. Suppose I assume L1 is finite, then finite union L2. That L2 has to be finite, then only result is finite. This is already given, so you can't change it. When this is finite, both L1 and L2 always finite. If any one of them is not finite, then this could have been not finite. So understand, when the result is fixed, in this case only, not other examples that I'm going to take in the future. In this question only, the result of two languages is finite. It means these two definitely finite, that I can say both L1 and L2 are finite languages without any doubt. There is no other way to prove it. In case if we take any one of them is infinite, then this L1 union L2 is finite statement is wrong. But already clearly given, the L1 and L1 union L2 is finite, is given to you. You can't change this statement by changing different L1 and L2. So this is fixed. But when this is fixed, then L1 and L2, is there any particular language like type L1 and L2 should be finite to get this result is finite. Okay, so with this, the question is about only L1, right? Okay, when it is L2 also same answer. L1 is always finite. When it is finite, obviously regular. Okay, but that is a strict answer, and L1 is also regular, because if it is MSQ, then definitely you can choose L1 is regular. When it is finite, both are finite, right? When both are finite, both should be regular. And we are only talking about the one direction. Okay, remember that. If we are also talking about this direction, should be very careful. You can't choose the option B. If and only if statement comes, L1 union L2 is finite, if and only if L1 and L2 are finite, that statement is different completely. In that example, the L1 you can't choose regular. If they are talking about if and only if, you have to choose the finite word only. So this is only one direction. It's okay. Already we know L1 is finite, and hence it is also regular, and we can't choose infinite. And I'm also giving, when you can't choose this regular, if word is not there, in place of then you have if and only if L1 union L2 is a finite, if and only if L1 and L2 are finite. You can't say regular word, because you should also apply other direction when they is if and only if. Okay, fine. Think about this if and only if statement if you understood this implication by implication properties. Next one, if L1 union L2 is infinite, then what is L1? You tell me, is it required to be L1 is infinite? I'm just saying that L1 union L2, this is given as what? Infinite. This is given to you. With this, can you conclude L1 is infinite, or L1 is finite, or L1 is regular? Let's think about. I'm talking about different cases. First option, I'm trying to fail it because I know that always not finite. If you want to fail it, I can take L1 is example is infinite. If I take infinite union L2, let me write other way. L1 is infinite. This case, only examples I'm taking, not all the time, only some examples. If L1 is finite, right? So our statement was correct. L1 and L2 is infinite. But is it always correct? When I choose L1 is infinite, this option is wrong. You are trying to say L1 is finite always, but that's not correct. Second, regular. Is L1 required to be regular? I can take L1 is non-regular, and every non-regular is, it's infinite too. The non-regular union L2 is also infinite. So this statement is also wrong. And third statement, C, I'm trying to fail it. They are saying that L1 is infinite. I'll take L1 is finite. Oh, is there any way that L1 is finite? But at this time, I have to take L2 is infinite. Yes, L2 has no restriction, right? I can take, in that case, you are talking about L1 is infinite, but I'm saying that L1 is finite, still the result is infinite. So finite union infinite is infinite. So L1 you can't say even infinite. L1 can be finite, L1 can be infinite, L1 can be regular. So there is no particular way to fix the answer. Okay, so need not be finite, need not be regular, need not be infinite. That's why we go for none of this. Okay. Very interesting question. Okay, let's move to the next question too. If L1 union L2 is regular, then what is L1? Very interesting, right? Yeah, this is one of the gate model question. Is regular language, then what do you say about L1? Somebody is saying that L1 is finite. I'll try to disprove it. L1 I'll take infinite. Still possible infinite union L2 is regular. That infinite I will take A star, something like that. In one example, L1 I take infinite, like A star. If I take A star union some, L2 I can choose anything, right? I'll choose the same A star. Then A star union A star is what? Regular. So that means I got a counter example for finite. Why the finite is wrong? I'm saying L1 need not be finite. L1 may be infinite. I'm just taking an example to disprove the option 1. Okay, just disprove the option 1. Now I'll go for the option B. Somebody saying that L1 is regular. Do you require L1 should be regular? I'll take L1 is A power n B power n. At this time, because I'm trying to say that L1 may be non-regular, to disprove the option B. At this time, I will take L2 is A plus B whole star or A star B star. In that case, A power n B power n union A plus B whole star, I got the regular. You know that A power n B power n union A plus B whole star. A plus B whole star is superset of everyone, right? The result has to be A plus B whole star. In this case, result is regular, but L1 no guarantee is regular. So this statement is also wrong. And third statement is somebody saying L1 is infinite, the third option. Now, is it required to be L1 infinite? I'll take L1 is finite, L1 is empty set. At the time, L2 you take any regular, the result is definitely regular, right? So I'm trying to say L1 may be finite. Take epsilon if you want to use some string. That's also fine. And L2 you take any regular. Take any regular. The result definitely regular, right? So L2 is not much not required here, or don't worry about L2 what you take. Try to fix the L1 as per the given options, but L1 need not be always, L1 need not be finite, L1 need not be regular, L1 need not be infinite. So this is how you can choose the options. You'll go for none of them. In the exam, most appropriate options that you may choose or you may see need not be regular. That is the best answer you should choose in case if you don't see the options like this. Okay. Next, L1 union L2 is non-regular. Then what is L1? I'm only talking about L1. In the exam, they may talk about both together L1 and L2. then you should be very careful. Together you have to think about. Now L1 union L2, result is non-regular, result only non-regular, that's given to you. But what is not given to you? What is L1 and L2? They have not given to you. You require to identify. Now the first option is talking about, is that L1 always finite? L1 always finite, is it true? L1 I can take infinite, that infinite union some non-regular, then of course the result take as non-regular. So first example, I'll just show that L1 is equal some non-regular, sorry, some infinite, forget about non-regular here, some infinite. Let's take a infinite, right? So which infinite you want to take? Let me take a power n, b power n. But to get the result is non-regular, maybe L2 take the same one if you wanted to prove it. So I'm just showing that infinite. So the first option, based on this, I will delete it. As you know, you can't say always finite. I got L1 is a power n, b power n. L2 also I take the same, then result is non-regular. Second option, somebody saying L1 is always regular. Is it always regular? Already this example can prove, right? Second is also, I'm just trying to say non-regular. This is a non-regular. How can you say it's always regular? Wrong. And infinite, can I take a finite? L1 union L2 is non-regular, but they did not mention L1 is infinite. L1 can be finite. I'll just take L1 is pi. It is a finite, but at this time I will take L2 is a power n, b power n, because result has to be non-regular. L1 can be finite. Now how can you fix it is always infinite? Wrong, because sometimes when L1 is finite, the result is possible to be non-regular. Okay, here L1 and L2 information is not given to you. Don't assume they are always non-regular. What is the difficulty here? The two statements that we always worry, like if L1 is non-regular and L2 is non-regular, at this time very clear what is L1 L2, then you can definitely say L1 union L2. Oh, you can't say that too, right? We have already proved it. It's also need not be regular, that is also we have proved it. Very dangerous statement, need not be regular. In this case also we got need not be regular when we are trying to see the union operation in the beginning. And the second statement, if both are different statements completely, if L1 union L2 is non-regular, still we do not know what is L1 and L2, then L1 need not be non-regular. It could be even finite, or it could be even infinite, or it could be regular. It could be possible anything here. Fine. Let's move to intersection. So before this, we have looked at union operation. I hope this is my first time in entire history that I'm talking about the union, nearly almost 60 minutes. But you will see when you are solving the gate questions how important this concept is, and this should give an idea how we approach the closure property. When we are talking about the closure property, you should think about in and out of the operation. Like if an input is given, what is output? If output is given, what is possible answer for input? So these things should come into the picture when you are talking about, or when you are discussing, or when you are learning about the closure property. So using this idea or having this knowledge, now we will go very quickly for intersection operation. Okay, let's start with L1 and L2 are finite languages. Then what is intersection? So I'm going to be a little bit quick, as you are aware what I'm doing in the union operation. Finite intersection finite. Any doubt about it? The finite intersection, the finite language. Finite intersection finite is, can I say, always finite without any doubt? Yes, always finite. So when it is always finite, it is also always regular. One direction only. Don't assume result is given to you, result you are finding. When the result is finite, that you can call it as a regular, but you can't call it as infinite. Okay, so this is finite and also regular, because every finite is regular. Let's move. Next, two languages are infinite, then what is their intersection is? Now think about here, infinite set intersection infinite set, another infinite set. Do not blindly, we should not assume that blindly result is infinite. Think about, do you get any possibility of finite? Yes, I'm just giving an example to help you. Like one of the infinite language, infinite you may take regular, non-regular, we don't care, but we are very good now with the regular languages. So I'll just helping with the A star intersection B star. Both are infinite, but that will not guarantee result is infinite. Result is just epsilon. You see that infinite intersection infinite, just epsilon. Why? In the A star you have epsilon, you have 1a, a square, and so on. Here in B star, epsilon, b, b square, and so on. But you see, only epsilon is common in both the languages. That's why result is epsilon. So this epsilon is actually finite. But that doesn't mean that all the time the result is finite, right? So in some other cases, let's say A star intersection A star only, the result is A star, but this is infinite. So what we can conclude, infinite intersection infinite need not be finite, need not be infinite. What about regular? Can you guarantee always regular? No. For that, you take the non-regular example, a power n b power n intersection a power n b power n. Still it is a power n b power n. So that's not regular, right? It need not be regular too. So we'll go for none of this. I hope you got a clarity what I'm trying to say. Infinite intersection infinite, it may not be finite, may not be regular, may not be infinite. So that's, I can't conclude any answer right now. So it's one of the interesting example. Nothing is guaranteed here. So may not be finite as for the option 1. As for the option 2, may not be regular, may or may not. You can use that statement. Or may not be infinite. That's why we are not choosing this ABC. Sometimes only, but not all the time. Okay, let's move to the another example. Both L1 and L2 are regular languages. What is this intersection? So like union, you can use the composition machine for proving union and intersection. So regular intersection, we have algorithm for this. Regular is always regular. No doubt about it, is always regular. You can use the same proof that you have used for union, only the final states in DFA will change because we are talking about intersection operation. Now, result is always regular as it is closed, right? So this intersection is closed. This intersection operation closed for finite languages, because finite intersection finite is what? Finite languages or finite sets, and it is not closed for infinite sets. Why? Infinite intersection infinite need not be infinite, not closed for infinite sets. What about regular sets? Yes, it's a closed for regular sets. Okay, so now I'm going to talk about the options. Can you say always finite? No, it may be infinite also. Like an example, A star intersection A star, result is A star, so finite you can't choose all the time. Regular, that's correct statement. Infinite may not be guaranteed. This regular might be finite languages. If both are finite languages, result could be finite. In that case, infinite is wrong option. So regular is the proper option. Next one. If both L1 and L2 are non-regular languages, non-regular languages really important, but you require some examples to analyze. So let me analyze for you. There is one non-regular and another non-regular. When you do the intersection, will the result is always non-regular? You already know for the union only not guaranteed, right? Now intersection, let's think about. Now I'm taking both are non-regulars. Example, a power n, b power n, well known non-regular. There is another non-regular, b power n, a power n. Assume n is greater than or equal to 0. In this, epsilon is there, another one ab, a square, b square, and so on. Now, when you look at it, here epsilon, when you put n is equal to 0, n is equal to 1, b a, and after that b square, a square. Now you look at that, when you do the intersection, the result is just epsilon, right? Result is just epsilon. That's a finite set. Finite set, is it regular or not? Obviously it is regular. Okay, this example is enough. Why we don't say always non-regular, right? It may be regular also. Due to this, we can say intersection is not closed for non-regulars. Sorry. This intersection operation not closed for non-regular languages domain. Even infinite languages also, this intersection was not closed. Only for finite languages and regular languages, this operation is closed. Now, what is the result? Can you always assume it is finite because there is option finite? No. There is an example. Same example you take a power n, b power n. Take the same example. What do you get? You get infinite, and which is non-regular, and also infinite. That means option A wrong. We can't choose the finite because sometimes infinite. Regular, we can't choose always regular because sometimes non-regular. Infinite is wrong because sometimes result can be finite. So what is the right answer? None of this. So non-regular, intersection non-regular could be anything. It may be finite, it may be infinite, may be regular, may be non-regular. So this is really question mark. It could be anything. Okay, that's why I have written question mark. That means it could be possible any. It depends on what non-regulars you take. Next. Now we are going different direction. Now result is given. What the input you have taken. Among them, I'm just asking about L1, but think about, take it as homework. Think about what happens to both L1 and L2. Both are finite, or sometimes one is finite, other is infinite, or both are infinite. Think about these things. When L1 intersection L2 is finite, the result is finite. Result is finite. Then is that guaranteed? Is that guaranteed? L1 is always finite. We know that L1 and L2 both are finite. The intersection is always finite. Intersection of those two languages always finite. But now, when the result is finite, is that L1 guaranteed always finite? You know that L1 sometimes can be infinite. See that. Let me take an example to disprove that option A. L1 I am taking as infinite. Like let's say a power n, b power n. Intersection, I'm just taking L2 as let's say pi. Enough. The result is finite. See, when the result is finite, no guarantee that L1 is finite. It could be infinite. So that's why option A cancelled. So here I'm possible. I'm not saying always. Possible, infinite possible. Infinite set possible. What about regular? This example enough. Also, it could be possible non-regular. And what about infinite? Is it L1 always infinite? I may take an example. I may take L1 is a pi and L2 you can take anything, and still that result is what? Finite. So now L1 can be finite. L1 can be finite set, but you are saying that it is infinite. Wrong. The answer is none of this. And what could be the right answer? L1 may be finite, may be infinite, may be regular, may be non-regular. So this many answers may come out for L1. May come out for L1. So keep this in mind how you conclude for L1. Similarly, L2 all the answers are same, like L1 can be, L2 can be finite, L2 can be regular, L2 can be infinite. But when you talk about both simultaneously, what happens to L1 and L2? See, is that possible? Both L1 and L2 are finite at the same time? Yes, possible, but not always. Is that possible? Both L1 and L2 are finite, infinite? Yes, that is also possible. Is that possible? L1 and L2 both are regular? Yes, that is also possible. Is it possible L1 and L2 both are non-regular? Then that is also possible. So many combinations which can give the result is finite. Okay, when L1 and L2 could possibly any. Another one, L1 intersection L2. Now this time is infinite. This time is infinite. So should be very careful. Whenever you talk about the infinite languages, we should have very clear idea what infinite we are talking about. Anyhow, here we are talking about any infinite set in the world, but you should have an awareness how to take infinite set into consideration to apply this intersection. Now you're talking about L1, right? Now tell me, when the intersection of two languages is infinite, is there any possibility one of the languages is finite? It's impossible. If one of the languages is finite, then whole result is finite. That means not only L1, even L2 cannot be finite. So L1 and L2 definitely should be infinite, but which infinite, that depends on what you take, right? So finite, impossible. Finite, impossible, because result is infinite, means both must be infinite. I can say that both L1 and L2 are infinite. It has to be. There is no other way that L1 and intersection L2 is infinite. You can't take L1 and L2 are finite. If you take any one of them is finite, the finite intersection anything is finite. If you know the point that you know that suppose finite set, you apply with any L, the result is always a finite. There is no doubt, result is always finite. Got my point? So you cannot take L1 is finite. That's why we delete it completely. This is even one case also you don't have to take L1 is finite. And what about regular? Okay, L1, the result is infinite. This infinite may be regular, non-regular, right? This L1 may be regular, may be non-regular. If I take non-regular, say a power n, b power n, intersection a power n, b power n, then result is infinite. So it could be possible non-regular. So sometimes regular, sometimes non-regular. So don't choose that. But what about infinite? Definitely this is the right answer. L1 has to be infinite. Not only L1, L2 should be also infinite. So both L1 and L2 should be infinite. So this is one of the best example. You can conclude something from L1 intersection L2 is infinite. Next, if L1 intersection L2 is regular, yes, this is very important for us as we talk about or we learn about regular languages. You should aware of what happens for this. First statement was very clear that if L1 and L2 both are regular, then intersection of both regulars, intersection of that two regulars is always regular. That was a closure property. But this is something different. Here what is given to you is L1 intersection L2 is regular. Will it guarantee L1 is regular? This is really a very good question for you. No guarantee that L1 is regular. Without L1 regular, still we can get L1 intersection L2 is regular. Without L1 is regular. So can you give me an example, sir? Yes, we will do that. That's what I am talking about. Requiring examples to understand. So I'm taking an example. I will keep L1 is non-regular, but still I will prove L1 intersection L2 is regular. Somebody is saying that L1 intersection L2 is regular. Now you have to prove L1 need not be regular. So I'm trying to prove that. I'll just take L1 is a power n, b power n. This is L1. Okay, this is L1. Now intersection, now I will take L2, but result is going to be regular. So I'll take L2 is empty set. Enough. I got result is regular or not. Empty set, result is empty set. This result is empty set. That means when I take L1 is non-regular, still you will get intersection is regular. Intersection of two languages regular doesn't mean that L1 is regular. Is that clear my point? Intersection of two languages is regular doesn't mean that L1 regular. But if both L1 and L2 are regular, then definitely intersection is regular. These two statements you have to write somewhere to understand and remember it. So first point, I'm saying that L1 need not be regular. What about finite? I have taken infinite till you got a regular, right? So you can cancel this, you can cancel this. What about infinite? Is it L1 required to be infinite? No, right? You can take empty set, empty intersection empty is empty, so need not be infinite too. So none of this is the right answer. 2 points keep in mind, that is, if L1 is regular and L2 is also regular language, then no doubt here L1 intersection L2 is definitely regular. Definitely regular. So only one direction. When I take intersection is regular, this is known now, this assumption now, then don't say anything about L1. It could be anything possible. Need not be regular. Best point is need not be. Simply you can say may not be regular. Keep this in mind. Not only L1, you can also talk about L2. L2 also you can take it as need not be regular or need not be finite, need not be infinite. All are correct statements. Fine. Intersection of two languages is non-regular. Where it goes is non-regular. What can you conclude about L1? Is it finite? I take infinite to prove it, right? First one, I'll take L1 is a power n b power n. L2 also you take the same. So I'm trying to disprove that option E. Option E, I'm giving counter example. I'm just taking infinite, right? L2 you may take same if you want it, just for easy. Now intersection is non-regular, so that means I can eliminate the option A. Somebody saying always finite, you are disproving them by giving infinite. And somebody saying L1 is regular. Oh, this is non-regular, so we already disproved it. Okay, this is non-regular. And somebody saying infinite. So now, if L1 is finite, I'm trying to find, is there any example that I can get a finite? If I take L1 is finite, you know that finite intersection L2 is the finite. You can't get non-regular. So first get the non-regular. When you take L1 as a finite, you will never get a non-regular. Means L1 definitely infinite, then only you can get the L1 intersection L2 is non-regular. Here this infinite is absolutely correct. L1 impossible to be finite. L1 never be finite. That we know. That what we don't know, L1 is non-regular or L1 is regular, that we don't know. We know that L1 definitely infinite. To prove that, L1 intersection L2 is non-regular. Okay, L1 intersection L2 is non-regular. It means you can somebody can conclude from it, L1 intersection L2 is non-regular, then both L1 and L2 definitely infinite. If it is any, if in one case L1 or L2 is finite, then you will never get a non-regular. That means you can conclude from this. Note, I'm just concluding it. If L1 intersection L2 is non-regular, then both L1 and L2 must be infinite. But which infinite, that depends on what language, what non-regular is the result. If both L1 and L2 are infinite, that's all we can conclude. Even we can't conclude whether it is regular or non-regular. That also we can't answer it. We can only answer infiniteness. Fine. If L1 and L2 are finite languages, now we are going for the another operation, set difference. I hope you might aware of this set difference, union intersection. Now we are moving to set difference. So before going to the set difference, just do the review of both, to do the revision of both. Union, if you want, I can make a table for you. Like union you have tried, intersection you have tried, just make a table just to have a all at one place. One is for finite sets, another for infinite sets domain. Different domain you apply this operation sometimes. Regular sets, regulars, another one for non-regulars. Okay, so now we have a revision table. You know that tick is for closed, cross mark for not closed. Now you tell me, fill this table based on the knowledge that you have, so that you can recall many points that I have discussed. Union of two finite languages is finite, so closed. Union of two infinite languages is result infinite, so that's why it's closed. Union of two regulars is regular. Union of two non-regulars, we have seen, need not be non-regular, so it is not closed. So recall that, and please, in case if you forgot these concepts, go back and learn it and make this table. Intersection of two finite sets is finite. Also remember, this is closure property, but in general, finite intersection, any language is finite, but here you have two operands are finite, so definitely finite intersection finite is finite. Infinite intersection infinite need not be infinite, that's why it's not closed. Regular intersection regular is always regular, and both of them we have the same composition proof. You can combine the two finite automata by doing the Cartesian product or using composition algorithm. And non-regular intersection non-regular need not be non-regular. Okay, so this is complete revision of both union and intersection. Let's move to the now set difference. I hope you are aware of set difference. L1 minus L2 means, suppose you have two languages, L1 and L2. I am assuming these are two languages. There are many strings here. Okay, in L1 and L2. This is L1 and L2. What is the meaning of L1 minus L2? Only the L1 portion. That means the result here depends on L1 only. But those strings which are there in L2, will be deleted from the result. In case, let's say L1 is equal to A comma AB and L2 is equal to A comma BB, then what happens? Result is L1 only. L1 minus L2 will actually depends on A comma AB only, but those strings which are there in L2 will be deleted. That's all. This will be deleted. The result is only AB. Result is only AB. Why A is deleted? Because this A is present here in L2. Those strings which are present in L2 will be deleted from L1. So this portion is called as L1 minus L2, which is simply only L1 portion. Those strings which are not there in L2, that will represent L1 minus L2. Okay, that's AB is not present in L2. In case A and AB both are present here, then you will get L1 minus L2 is empty set. Fine. Now come to the question. If both are finite languages, what happens in L1 minus L2? L1 is given as finite minus L2 is also given as finite. What happens? Both are given. L1 is given, L2 is given. Then what happens to L1 minus L2? Finite minus finite. Remember one point. You have already one note. Finite intersection finite is finite. But that's okay. Not only this, finite intersection, any language, whether it is finite or infinite, doesn't matter. That is also finite. Now I'm talking about infinite. Sorry, set difference. Finite minus finite. See, you have a finite set. From this finite set, you delete finite only. Remaining set will be finite only, right? It's not possible to be infinite. That is always finite. Not only this, from this finite set, you delete any language or you do the set difference with any language, you will again get finite. So these two properties are very interesting, intersection and set difference. From the finite set, assume you have a box, in this only finite strings are there. Delete anything, you will left with finite only. You delete finite or delete anything, you have to left with finite only. Either empty or non-empty, but you have to left with finite only. So finite minus finite is always finite. Now coming to the options. Finite is right option. Regular is also right option. Why? Because every finite is what? Regular. Every finite is what? Regular. Infinite is never be. Okay. So both it's actually finite, hence also regular. Hence also regular. In the exam, if you don't see the finite option, you can choose the regular as an option. Infinite, intersection infinite. Two languages are given as infinite. Infinite minus INF. Just assume that it is infinite language. Infinite language minus infinite language, the result. So from the infinite, you delete the infinite number of strings. From the infinite language, you delete infinite number of strings. Is it possible to be finite? Is it possible to be infinite? Both cases are exist. Both cases are exist. Is it possible to be regular? Possible. Is it possible to be non-regular? That means everything you can conclude here, but not always. Possible only. So I'm just trying to prove. First one, I'm trying to produce a counter example for this. I'm going to take result is infinite here. When do you take? Suppose I have a power n, b power n. I'm trying to delete minus. Let's try to delete b power n, a power n. What happens? From this you can delete only one string, right? From this we can delete only one string. What happens? Result is a power n, b power n. You will not have 0. So greater than or equal 1 will happen. By default it is greater than or equal 0. Epsilon only deleted because remaining all strings are different from this. So remaining all strings except epsilon will come here. So it's infinite. It's what? Infinite. Result is infinite. Now the question is infinite minus infinite. Infinite minus infinite. Did you get infinite? But the option is saying finite. So wrong. Now is it regular? We got here non-regular. The same example enough to disprove it. But is it possible to be infinite? This is my question. The second example will come out. Infinite minus infinite. Why are you taking two different examples? Take the same a power n, b power n minus a power n, b power n. You will get empty. You get empty. So this is finite. So this is also wrong. You can't say always finite, always regular, always infinite. What you can say is maybe finite, maybe regular, maybe infinite, but not sure. So infinite minus infinite, anything is possible. So I'm just leaving to you, but we are clearly we are talking about infinite. So I can say that need not be infinite. Okay. But you can also say need not be finite, need not be regular. All you can say. Now, because of this reason, the set difference is not closed for infinite. What about finite? Finite minus finite was finite, right? We have seen just before this, and hence the set difference is closed for finite language. Okay, closed for finite languages. So can you think about the regular language minus regular language? Is it always regular? Okay, if you know the algorithm, the composition, the FA1 cross FA2, this algorithm is enough to prove union, intersection, even set difference. All the three operations are having an algorithm that is a Cartesian product of two finite automata. You can do the compose and then you can get union and intersection and set difference of two languages with the help of the compound machine. So regular language minus another regular language which is going to be always regular, always. But what you don't know, it may be finite, may not be. It's always regular, need not be infinite. It could be possible as a finite. So only what we can conclude, regular minus regular is always regular. Finite and infinite may or may not happen. Depends on example. In general, it's need not be finite, need not be infinite, but always regular. Always regular. So the same proof is also applicable for set difference operation. Oh, non-regulars. Really, you don't have any particular machine for just non-regular, right? That's why you don't have a proofs. You will have mostly examples, or you will have some conclusions from the language when you apply the operation. Let's talk about this. Non-regular difference or set difference with another non-regular or same non-regular. Non-regular minus non-regular. Now you have to think about, see, you have only 3 options here, right? Another option is non-regular. So think about all the cases. Do you get finite? Do you get regular? Do you get infinite? Do you get non-regular? Think about all the possibilities. Non-regular minus non-regular. Non-regular in the sense you have to take infinite only, and that too non-regular. Infinite and non-regular, because the finite never be non-regular. So here I'm just taking some examples to disprove one by one. I'm trying to get infinite here. I'm trying to get infinite here. So already you have taken example, right? A power n, b power n minus b power n, a power n. We already seen that. You got the result is non-regular. And not only that, you got infinite. So just previous example only I am considering, like infinite minus infinite. When you did it, the same example I took. Right, you got a power n, b power n, so that n greater than or equal to 1, except n equals 0, everything is possible. So infinite possible, but you are saying always finite, so wrong. Option B, same example, will disprove the regular. Right, you may get a non-regular, so regular is always wrong. And what about the infinite? Is it always infinite? Non-regular minus non-regular, is it always infinite? No. Just take same example, non-regular minus non-regular. Same example I have taken. I am saying that the result you got finite, result you got regulars. That means even this is also wrong. You go for none of this. Okay. So understand how you should take an example to perform non-regular minus non-regular, non-regular union, non-regular, non-regular intersection, non-regular. These are really interesting questions for the exam point of view. Okay. If L1 minus L2 is finite set, then what is L1 or what is L2? What happens to both L1 and L2? Think all the possible combinations. We will be discussing about L1 here. If L1 minus L2 is finite, it means the result of the set difference is finite. Then what could be possible to be, or what could be possible at L1 side? Is that L1 always finite? Is there any case that L1 possible to be infinite? So I'm trying to think a counter example for the option A. Even L1 is infinite, is there any possibility of result is finite? Just think an example. Think about an example. I'm just taking L1 as an infinite so that I can eliminate the option A. Here I'm just taking, that a power n, b power n, which is infinite, and I'll just take the same one as I can take anything about L2. I'm just taking it. So now the result is definitely pi, right? Here I just took infinite, still result is a finite. There is L1 may be infinite. That is the reason I am deleting option A. You cannot guarantee always L1 is finite. As I have shown clearly example, my result is finite, but L1 can be infinite. My result is finite, but my L1 can be infinite. Now option B, this example is enough. It is not regular, right? It's non-regular. It is non-regular. So now non-regular, when the result is finite, L1 can be non-regular. So this is also eliminated. Now option C, this example cannot prove, right? I'm just trying to think counter example for this. When L1 possible finite, result is definitely finite, right? If L1 is finite, result is finite. Now result is finite, L1 possible to be finite. So second example I'm taking, any finite you take, I'm not restricting which finite, any finite you take, put any L2 here, the result is always finite. So we want result is finite. Now L1 may be finite, maybe infinite, maybe non-regular, maybe regular. So all the things are here. So answer is none of this. You cannot guarantee any of these options A, B, C. Now when you talk about both L1, L2, then both L1, L2, some things I can, we may talk about, like both L1 and L2 are finite. Is there any such situations that happens? You can see, is it always both L1 and L2 are finite? Not always, right? Sometimes both L1 and L2 can be infinite. So some situations or conditions might guarantee both L1 and L2 will satisfy with some languages. But in this example, talking about both L1 and L2 may not be appropriate, right? So when we are having the intersection, like L1 intersection L2 is non-regular, then we know that both L1 and L2 are infinite. So some certain situations, both L1 and L2 are guaranteed to satisfy particular language. Here it's okay. Here we are not able to conclude it, but you should think about. That's what I'm talking about. When I thought that when I was thinking about L1, you got L2 answer also. You can also think about L2. L2 may be finite or maybe infinite, maybe regular, maybe non-regular. Do you get all the possibilities? That's your homework. You just think about what's possible for L2, because it's a difference when left operand, right operand. When you think about left operand, right operand, could be possible different answers sometimes. So I'm giving a homework. Think about L2. What could be possible for L2? Is there any particular answer for that? Okay. Now, L1 minus L2 is infinite. Then what is L1? L1 minus L2 is infinite. Can you talk about something about L1? See, if L1, is that L1 possible to be finite? In case if L1 is finite, the finite minus anything is finite, right? So there is one thing, L1 never be finite. That means this is purely or always false. You don't have any example to prove that L1 is finite. You have to take L1 is infinite. Then only there is a possibility. I'm not saying always. There is a possibility to get infinite. If it's very clearly result is given as infinite, then we know that L1 never be infinite. So I'm just deleting by property of set difference. What about regularity? Is there any possibility of non-regular? Non-regular minus L2 is infinite. Yes, it could be possible. Non-regular means just take a power n b power n minus L2. You can take empty set. Then definitely will get a power n b power n. So here I can take some example, a power n b power n minus L2. L2 I'm just taking as pi. This is I'm taking it as pi. You just prove it as infinite only. So here I got this is infinite and this is non-regular. These two examples are, this example is eliminating two options. No, option C. L1, is it always infinite? Yes. This is what an interesting example or an interesting question you have. L1 has to be infinite when L1 minus L2 is infinite. There is no other way that L1 never be finite. In case you give me one example, finite minus L2 is infinite, impossible. I told you when L1 is finite, you delete anything, it has to be finite only. But here the result is infinite, it means L1 never be finite. Only when you take L1 as infinite, then L1 minus L2, you can prove it as infinite with L2 choices. So here L1 always infinite. L1 always infinite. But when you talk about L2, maybe answer may change. The L2 may be finite, may be regular, may be infinite, or may not be finite, may not be regular, may not be infinite. You should think about separately. Okay, so but don't choose for L2 also same answer. Maybe L2, for L2 it could be none of this. Just think about it and take it as homework. If it is L1 minus L2 is infinite, then what about L2? What about L2? Next, L1 minus L2 is regular, then what is L1? Okay, is regular, then what about L1? So now I'm talking about L1. In the first case, is there any possibility of L1 is infinite? Infinite minus L2. Can I prove regular? Yes, you can prove, right? I'm just taking A star minus pi. Still you got regular, right? It's just A star. It's regular. Now we have a regular, but what is L1? L1 possibly infinite. So this finite, always finite is wrong. Is this always regular? That you have to think about. Is there any possibility of non-regular case? Is there any possibility of non-regular case? I'm just showing it, A power n, B power n. But think carefully, when I do with sigma star, what do you get? Pi, right? But pi is regular. I didn't say regular is infinite. Okay, regular, but here L1 is what? Non-regular. But you are saying it is regular. I have shown that L1 minus L2 is regular if I choose, sometimes when I choose L1 as non-regular. So you can't assume that L1 is always regular. Now, is it possible that, is it always L1 is infinite? Now think about again. I take finite, like say pi, the third case. I did not choose this. So pi minus, choose any L2, that's your choice. But still I get regular, right? What is regular? Pi only. Pi minus anything is pi. Empty set, right? Empty set minus L2 is always empty set. So you don't assume that always it is infinite. It could be possible as sometimes finite. So wrong. So answer is not this. So what did you conclude? L1 is maybe finite, maybe infinite, maybe regular, maybe non-regular. You have all the possibilities when L1 minus L2 is regular. When L1 minus L2 is, if L1 minus L2 is regular, you get all the possibilities for L1. Now your homework is think about L2, what possibilities you have. Okay. Now L1 minus L2 is non-regular. When it comes to non-regular, spend enough time. Even for me sometimes looks you need to focus much to get an examples, as you should aware of a lot of non-regulars to give an examples. Fine. Now for this I am trying to give examples here. L1 minus L2 is non-regular. Now your focus is on L1. L1, is it possible to be infinite, so that I can eliminate this option? Infinite minus L2, will you get non-regular? Yes, obviously, right? I've just given an example already. A power n minus B power n minus, I'll just do B power n minus B power n A power n. So definitely you will get non-regular only. So same thing you will get, but n greater than or equal to 1. So that is non-regular. So I just took infinite to give counter example for option A. So you are saying that L1 is finite. I am showing that there is a possibility of L1 is infinite. And L1 you are saying regular. Of course this question is saying regular, and now I'm just showing that an example L1 may be non-regular. So this option is also wrong. And in this option C, you're saying infinite. You're saying this option saying infinite. Is there any example you have L1 is finite but result is non-regular? Impossible. Why? Finite minus anything, you will get a finite that is regular. So here you can conclude that L1 has to be infinite at any cost to get the result as non-regular. So it is another interesting example you have. But which infinite I'm not talking about? I'm not talking about every infinite, but whenever L1 minus L2 is non-regular, you will get definitely L1 is infinite, but some infinite. Okay, L1 definitely infinite at any cost. Now think about L2. If you want to take it as homework, what happens to L2 when L1 minus L2 is non-regular? Okay, we have another interesting operator or operation, which is a concatenation. I hope you are aware of concatenation. It's nothing but there is a sequence, one followed by other. Like here, all the strings of L1 followed by all the strings of L2 will get many combinations when you are trying to produce a language. Okay, So now here given as the two languages are finite, one finite language with another finite language, finite dot finite, will you get another will you get the result always finite? Is there any way that to produce infinite? No way, right? When you take finite number of strings here also finite number of strings, the combinations that you will see finite only. The result is always finite without any doubt. You will always get a finite set here, correct? So answer definitely finite. Hence it is also regular, but infinite definitely wrong. Okay, very simple question. Therefore you can conclude that concatenation is closed for finite languages. When you take two finite languages, perform the concatenation, then you will get the result always finite. So I can say concatenation is closed. This is closed for which domain? Closed for domain is finite languages. So closed for finite sets. Closed for finite sets. Next one. When L1 and L2 are infinite languages, then what is the concatenation of these two infinite languages? So infinite set dot in another infinite set, what will be the result? And is there any possibility of finite? Possibility I'm talking about. Can you try? There is an infinite set, there is another infinite set. When you do the concatenation, impossible to be finite. So this impossible. Why is that? Because see, you take one string from this infinite set, already there are infinite strings. When you do concatenate with one string, you will get infinite. Okay, so infinite followed by the infinite language concatenated with another infinite language, you will get always infinite set. Of course you may take the same infinite set if you wanted, still you will get infinite set. Okay, what about regular? What about regular? There is infinite language, you are doing concatenate with another infinite language. Regular may be possible, but can you guarantee always regular? No, we can't guarantee. So you can't say that too. It may be regular, but not always. You may wonder, sir, how infinite set followed by infinite set? Is there any example for regular? Yes, you can produce a plus b whole star by taking a lot of combinations, but yes, you have example. I'm giving homework for you. There is infinite language concatenated with there is another infinite language. You may get the result is regular. You may get. So I am giving one more homework for you. Just try an example to get one example to get regular. But most of the cases you get non-regular. Few cases you will get regular. Think about it. But are not always regular. What about infinite? Yes, infinite followed by infinite. You have to get infinite. There is no doubt. So this is the right answer. When both the languages L1 and L2 are regular, then what about the concatenation of two regular languages, right? So regular language followed by another regular language. When you perform the concatenation operation, you always get regular. You have a lot of algorithms. Dot itself a proof in regular expression. Take one regular expression, put a dot and write another regular expression. You will get a new regular expression that will solve your problem. For this regular language, you write regular expression. For another regular language, you write another regular expression, put a dot in between these two expressions. You get a new expression to produce this result. Okay. Now the question is what? The result, is it always finite? No, need not be a finite in general. It can be finite or it can be infinite sometimes. Now what about result? Regular? Yes, it is always regular. But is that result always infinite? No guarantee. Example, suppose I have regular, another regular is empty language, then result you get empty, right? So now the result need not be infinite. I am saying sometimes you may get finite, like empty set. Like here empty set possible when one of the regular language is empty. So it sometimes the result could be finite, sometimes the result can be infinite, but always infinite is wrong. Okay, so correct answer is regular. L1 and L2 are non-regular languages, then wow, really interesting and not easy question for me at all. Non-regular dot non-regular. Already, very simple languages. This looks very difficult. Now we have to think about non-regular. There are infinite non-regular languages in the world. And now you need to think about under which cases you will get finite, under which cases you will get infinite, under which cases you will get regular, under which cases you will get non-regular. Is there any possibility if you have it? Otherwise, okay. Non-regular is already infinite. Another non-regular is already infinite. Infinite dot infinite is always infinite. So finite impossible. So we can guarantee infinite, no doubt. A non-regular dot non-regular. Is it always non-regular? Because you have a regular. If we have one more option non-regular, will you have always non-regular? And that too difficult to say. So it could be possible that maybe regular sometimes, but not always. Okay, so not always non-regular, not always regular. So sometimes regular, sometimes non-regular too. So one thing is guaranteed, it is always infinite, but maybe regular, may not be regular. It's always infinite, but sometimes you will see answer is regular, sometimes you will see non-regular. Okay, that depends on what examples you take. You may ask again, the previously I have given homework infinite dot infinite, you get a regular example. So I'm just trying to give one simple example. See, when you have a power n, b power n, concatenate with, assume here n greater than or equal 0. And just one more language which its complement I am talking about. Its complement, but take the union with epsilon, union with just epsilon. Now the result you will get a plus b whole star. You just think about it. See, both are non-regular, but their concatenation is regular. So this example is enough for previous homework and this question. Infinite dot infinite, there is a possibility of regular. Non-regular dot non-regular, there is a possibility. I'm not saying all the time, that sometimes only. That's why I've written sometimes regular, sometimes non-regular. Okay, so this is the best example I can show that yes, regular possible, but not always. So you should be very careful about this kind of questions. Non-regular dot non-regular, that's non-regular concatenation with another non-regular. You have to be careful, the result may be regular. So in the exam, this kind of questions you may face, so be ready for this kind of questions too. Another one, concatenation of two languages is finite, then what is L1? Okay, so L1 dot L2 is given as finite, but we don't know what is L1 and L2. It could be anything, right? Now your question is, assume L1 is finite, then is there any possibility of infinite? If there is any possibility of infinite at L1, then the L1 is finite. Wrong. So now I'm trying to prove that the result may be finite in one situation. Suppose L1 assume is infinite, but I'm putting L2 is just empty set. Empty set is a finite under special conditions. Now L1 is equal to infinite, L2 is equal to pi, then what happens? Anything dot pi is pi, pi is finite set. So here L1 you are assuming finite, but that is wrong. It could be infinite. So I am deleting it. I'm deleting it. Fine. Second point is that L1 regular. I'm just trying to think about L1 is non-regular. Get an example. L1 is non-regular. So that L1 dot L2 is finite, then this statement will be deleted. This option will be deleted. In any case, non-regular dot L2 is finite. Again L2 I will take pi. Same proof, right? Delete. Now the option C saying that L1 is infinite. It's okay, I'll try. L1 is, I'll try to take the finite dot L2 I can take any finite now. Then finite dot finite is always finite. Take L2 anything, even you take pi or you take anything, any finite is fine. That's enough to delete the option C. That means none of this is correct. It means that L1 may be finite, may be regular, maybe infinite, or even maybe non-regular. Okay, so it's a very interesting question for the L1 dot L2 is finite, and you know that L1 and L2 both are finite. Definitely L1 L2 is finite, but if L1 L2 is finite, we don't have a restriction on L1. Okay, converse, very important statement. Next, L1 L2 is infinite, the result is infinite. Can you think about L1? Now option A says L1 is finite. I'll think about L1 is infinite. Is there any situation that L1 you will get a finite? Is there any situation? First I'm thinking about it. If L1 is finite dot and L2 may be infinite, then finite dot infinite, yes, possible to be infinite, right? Possible to be infinite. So L1 possible to be finite. I thought initially L1 never be finite, but no, that's not correct. Okay, now L1 I'm thinking about infinite. So I'll just say that one case L1 is equal, let's say A star, and L2 you may take same or different one, that's fine. L2 is equal any infinite, that's enough, right? Result we got an infinite, but L1 not guaranteed to be finite, so this is infinite. It means that option A is wrong. I'm trying to produce a counter example rather than thinking about finite, because infinite examples are there for finite. L1 as a finite, then we may not get the proper conclusion. So I always go for the counter example to delete it. Okay, we are not able to delete the option A, means there could be a generalized reason why this option A is correct. Okay, let's go for option B. L1, is there any possibility of non-regular so that the result is infinite? Obviously it's right. You can take a non-regular. L1 is non-regular, like A power n, B power n. Then L2 you may take the same or different, you will get infinite, because non-regular represent already infinite. And L2 you take any non-regular or infinite, the result is definitely infinite. L2 you take any infinite, that's enough to delete this option, because you may have L1 lot of regular examples, but you also have L1 as non-regular. That's why I have deleted option B. What about option C? Is that L1 always infinite? Is there any possibility of L1 finite? Yes, I'm just taking L1 is finite. Finite in the sense, let me take one string only. That L1 I have taken. L2 you take any infinite, then it will produce infinite, because A you have to concatenate with lot of strings, then result definitely infinite. That means assuming always infinite is also wrong. In this situation, when L1 dot L2 is infinite, the L1 could be possibly any of this. So not always finite, not always regular, not always infinite. So we deleted options. We go for none of this. L1 L2 is regular, and always this kind of questions required for the GATE exam. You see a lot of questions, rather than asking like L1 L2 given and what is that operation over L1 L2, very rare questions. But L1 L2, L1 and L2, that like L1 dot L2 is given to you, but what is L1 and what is L2? Such questions are preferred in the exam point of view. Now what is L1? Is it always finite? Is there any possibility of infinite? The option A, I'm just taking L1 is equal A star, and L2 you may take, let's say, B star or anything. It's just could be finite also sometimes. A star dot B star is already regular language, but L1 is here infinite. But option is says L1 is finite, so I can delete it. It's possible to be infinite, so you can't choose finite. Is that always regular? L1 is regular? Is that always L1 is regular? Is there any example L1 is non-regular, but L2 anything you choose, result should be regular? So I'm just choosing L2. You can take any non-regular in the world. I'll just put L2 is pi. Enough. L1 dot L2 is pi, then pi is always regular. This is always regular, right? So think about L2, sorry, both times I've written L2, sorry, L1. This time L1 can be non-regular. L1 can be non-regular. Any non-regular you take, I have no restriction. You take any non-regular, because already I restricted L2 to the pi, you got the result. Now someone says that L1 is infinite. Is that L1 always infinite? Can I put L1 is finite? In the finite, I just take empty set. Enough. You take any L2, I don't care. Okay, L2 is any. The result definitely regular. So infinite is also wrong statement. L1 you can't assume always infinite. So it may be finite, it may be non-regular, it may be infinite. So all the possibilities we have. L1 may be regular some situations too. So none of this would be the appropriate answer. Now L1 dot L2 is a non-regular. Result is non-regular. You're getting non-regular, right? Getting non-regular. Can you conclude something about L1? First one, option 1. Somebody saying L1 is always finite, but I'm trying to produce counterexample. L1, I'll just take infinite. Infinite in the sense, let's take A star, and I'm just taking L2 is A power n, B power n. So this will give you non-regular, no doubt. A star followed by A power n, B power n will give you non-regular. So here I'm just trying to put infinite to produce a counterexample for option A. So it need not be finite, it may be sometimes infinite. What about regular? So I'll just put reverse. A power n, B power n, where L2 I take B star. Fine, it's non-regular. But still A power n, B power n dot B star will produce non-regular. As number of base more than number of A's when you have A's followed by B's. So this is also wrong. Is that L1 always infinite? Is there any case that if I put L1 is a finite, if I put L1 is finite, still you get L1, L2 non-regular? Let me try. I'm just putting L1 is epsilon. Epsilon is a finite, right? Only language has one string. L2 you can take anything like A power n, B power n. You got a non-regular? Yes, epsilon dot A power n, B power n, again A power n, B power n. So infinite is also wrong because sometimes possible as a finite. You will choose none of this. Okay. Do you assume L1 is always non-regular? No, we already have some examples which are regular. So L1 need not be finite, need not be regular, need not be infinite, need not be non-regular. Now with this, we have some important points, like you have blend, union, intersection, difference, concatenation, complement. I think we have others yet to come, like clinic closure, subset, many things are there. But let's answer some of the questions that we have already done. Which of the following operations is closed for finite languages? Finite languages, we are talking about closed. Union, finite, union, finite. Is it always finite? Yes. So it is closed. I'm talking about closed. Intersection, finite, intersection, finite. Why I'm taking only finite? Why I'm not taking regular or infinite? Because domain is already fixed. Okay, this is talking about domain, right? So we should think about only finite languages to take as an input. So finite, intersection, finite. It's always finite. So means closed. It means closed. Difference, finite minus finite is always finite. So option A, B, C are correct. So it is MSQ type, and you should choose union, intersection, difference. All are closed for finite languages. Okay, and go back and just look at what we have seen. Finite union finite is finite, finite intersection finite is finite, finite difference with the finite is finite. Next, which of the following is closed for infinite languages? Now domain is infinite languages. We have the set, we have the domain in which only finite sets, infinite sets are there. Now union, infinite, union, infinite, definitely infinite, so closed. Infinite, intersection, infinite, we have seen result may be finite, result may go outside the domain, that's why it is not closed. Difference, infinite set minus with another infinite set, you may get finite or infinite, right? We have seen this too, so it is not closed. So here union is closed for infinite languages. If you are applying intersection or set difference, you may go outside the domain, that means result may be finite. Next, which of the following is closed for regular languages? As I'm going little bit quick here, the reason we have already discussed it, just I'm revising you, whether you had this in mind or not. Okay, next, domain is regular languages. Domain is regular languages. We have regular languages. Now union, regular, union, regular. Is it always regular? Yes, closed. Intersection, same algorithm. Composition, Regular, intersection, regular. Is always regular? Yes. And set difference. All the three have the same algorithm. In fact, only the final states in the machine will differ if you are taking the proof or if you are doing the proof. Which of the following closed for non-regular languages? Of course, nobody dares to do that. But as you know, the gate is all about the how do you apply your knowledge once you learn these basic concepts. Okay. Now you have the domain where you have non-regular languages over particular sigma. Union you are applying. Non-regular, union, non-regular. Do you get always non-regular? Do you get always non-regular? So I told you already that a power n, b power n union, its complement, it will give you a plus b whole star. So the result need not be non-regular. So union is not closed. Okay. Intersection, non-regular, intersection, non-regular, you may get regular also sometimes. That means you are going outside the domain. Indifference, non-regular minus non-regular. You take the same non-regular, right? Same non-regular you do set difference, you will get empty language. That's not non-regular. It is regular. So difference is also not closed. So these three operations are not closed for non-regular languages. Now, just asking different way. Previously, I've given the domain. I'm asking about the operation. Which of the following operations is are closed? Now, union is closed for which domain? A domain has the finite languages, domain has infinite languages, domain has regular languages. You need to apply separately now. Union, apply for finite languages, closed. We are talking about again closed. Infinite, union, infinite is always infinite. Regular, union, regular, yes. So all these three domains are closed under union operation. Next, intersection operation is closed for which domain? Finite, intersection, finite. Definitely finite, so closed. Infinite, intersection, infinite. Need not be infinite, so not closed. Regular, intersection, regular is always regular, so closed. Okay. Next, difference is closed. You should read, because sometimes they ask not closed. Then you should think about which are not closed. Now, domain here. Difference is closed, means finite minus finite. Is it always finite? Yes, so closed. Infinite, the difference with infinite. Need not be infinite, not closed. So go back and look at the examples that we have taken and conclude this. Regular, set difference with regular. Obviously, it is regular. We have the proof too. So finite and regular domains are closed under difference operation. Concatenation is closed for which domain? Finite dot finite. Is it always finite? Yes, so closed. Infinite dot infinite. Is there any case that you get finite? Impossible, right? So it's also closed. Infinite dot infinite. It has to be infinite. It has to be infinite. Regular. Regular dot regular. Yes, it is regular. The concatenation dot itself is proof in the regular expression why concatenation again produces a regular language. If L is finite, now we are going to the complement operation, one of the important operation in this closure properties. Without this, it looks like the closure properties is not complete topic. So even though you learn union, intersection, concatenation, set difference, still complement is more important than them. Okay, now L is a finite set over alphabet. Then what is the complement of L? Look at that. L is what? A finite. What is the complement of definition? Forget about this L. Now let me talk about the complement definition. L complement definition is, from the whole world universal language, you need to delete L. This is a complement definition. Now somebody is saying that you want to do the finite set complement. You want finite set complement. What you have to do, from the sigma star, you have to delete that finite set. And you know, the sigma star is already infinite set. From this infinite, you delete the finite. still you will get infinite. This old result is actually some infinite. Definitely some infinite set. So finite set complement of finite set is never be finite because of this complement definition. Because of this complement definition in theory of computation, when we do the complement of a language, we do subtract with the universal language, right? Given language is here, and sigma star minus given finite language will always produce infinite, because sigma star is infinite. The universal language is infinite language or infinite set. Now come to the conclusion. The finite set, the complement of L, definitely not finite. As I just explained, definitely not finite. Is always infinite. That's true. L complement is infinite, no doubt. It's not because of just complement, it's because of the definition of a complement. Sigma star minus finite will produce infinite. Okay. And what about regular? Is that going to give you regular? Now I'm asking you definition again. The finite set complement is actually what? Sigma star minus finite set. Now you tell me, the finite set is already regular or not? Regular. Complement of regular is always regular. So complement of finite is always regular. Whether the result is finite or not, we don't care here. Just to give you a regular definition. L is already regular, so L complement has to be regular. Sir, how do you say that regular complement is regular? It's going to come next. But what is the proof you have? We have a very simple proof that for a regular, assume L is finite or regular. For that, you design a DFA, interchange final, non-finals. You will get another DFA that exactly accepts complement of given regular. Okay, we have an algorithm. After constructing DFA for the given regular language, you can interchange final, non-final. You get a new DFA that exactly accepts complement of regular. Okay, very simple algorithm. So now can I say that if L is the finite, its complement has to be regular, even though it is not finite, so it is definitely correct. So by concluding this, you can say that the result of the complement of finite set, it's going to be regular and infinite. Not only regular, it also satisfies infinite. Okay, regular but infinite. So we got the answers. It's infinite always, and also it's regular always. Next, L is infinite set over the alphabet. Then what is the complement of this infinite set? Complement of infinite set. Like I want to sigma star minus infinite, but what kind of infinite it is? What kind of infinite is? Do you know that? Is it regular or non-regular? We don't have any awareness because arbitrary infinite language. Is there any possibility of infinite? Yes, but is it always infinite? No. Right. Result again, when you do sigma star minus given infinite, this result may be finite, because see that from the sigma star, if I delete again sigma star, you will get empty language because sigma star is infinite. So this infinite, if I assume the same sigma star here, the result will be empty. That's finite. But is it always finite? No. If from the sigma star, suppose I delete a star, then so many strings left in the sigma star, you will get infinite. So here you may get finite or infinite. The result you may get either finite or infinite, or maybe regular, or maybe non-regular. Anything is possible. Anything is possible. So you may ask, so how do you get regular? That sigma star minus sigma star, when you do it, it's possible to be regular. Empty set is a regular. How do you get non-regular? This infinite, I take a power n, b power n. Then sigma star minus a power n, b power n, it's nothing but complement of a power n, b power n. That's non-regular. So all are wrong, because you are saying always finite, always infinite, always regular is wrong. But if you say sometimes finite, that's correct. Sometimes infinite, sometimes regular, if anybody forms that options, they are correct. Right now, none of this is correct. So what is infinite complement? Anything is possible. Right? Need not be finite, need not be infinite, need not be regular, need not be non-regular. You just say anything. That's right. I'm just leaving it because all the choices are correct. If L is regular set, then what is the complement of L? Regular complement. This is what I am talking about, right? you will get always regular. You will get always regular. If complement of regular is always regular. Always regular. Okay. Now what is the proof that I am talking about? Now see, take any L that is regular. What you do is construct DFA. After that, just interchange finals and non-finals. In this DFA, all the finals convert to non-finals, all the non-finals convert to finals, but don't change the transitions. Transitions number of states same, and you will get modified DFA, right? Some modified DFA you get, some DFA you get, and this DFA will accept L complement. So now when L has a DFA, L complement also has a DFA. That is the reason regular complement is regular, regular complement is regular. So I'm proving that this result has a DFA. You know that any language has a DFA, that means that language is regular. This is complete algorithm why complement of a regular is regular. So now we have a conclusion that regular complement is regular. But now come to the point, finite. Is it always finite? No, right? Regular may be infinite. So when the complement of infinite you do it, it could be anything. So always finite is wrong. Always infinite is also wrong, because some of the regulars, when you do the complement, you may get finite language too. Regular complement is always regular. That's what we have here, and this is complete proof. It's algorithm how you prove that complement of a regular is regular, because I have shown that this complement of regular has a DFA by taking the given regular has a DFA by taking the DFA for given regular, and in that DFA we just interchange finals and non-finals. Very nice. If L is non-regular, then what happens to complement of this non-regular? Okay, sometimes we write if then, but some of the statements converse also holds. You should know that. Let me write some point here. If L is regular, what did we say? L complement is regular. But I didn't say that. There is one more point left here. If L complement is regular, actually L also regular. It's a very interesting point. You see that L and L complement. If anybody has a DFA, in that DFA interchange final non-final, you will get its complement. That means by observing these two statements, you can say L is regular if and only if L complement is regular. See that when these two statements are holding, then you can write the if and only if condition between L and L complement. Okay, these three statements are very important. We are always speaking of this if then, but sometimes the converse also true, then if and only if is appropriate. With this help, you can assume that if this is non-regular, it means L is not regular, the L complement has to be not regular. If you know the by implication, you can easily conclude. Why? Because if L is non-regular, you can't make a DFA for L complement. In case if you have a DFA for L complement, you will definitely have DFA for L. So you think how I am going to conclude. Simply you can say that L is non-regular if and only if. This statement also gives another meaning. L complement is non-regular. Right? When I am writing this statement can be concluded. When I am writing this statement is also possible to be concluded. Right? So now can I say that if L is non-regular, then L complement is non-regular. If L complement is non-regular, then L is also non-regular. So many statements. Other two statements are not writing. Just these two statements you copy paste here. If L is non-regular, then L complement is non-regular. Just add here non, and similarly here also. Okay, those two statements you can copy paste here. But really very interesting question now. If L is non-regular, then L complement is definitely non-regular. So you take any non-regular, do the complement, result is always non-regular. So is it finite? Never. Non-regular never be finite. You know that. Is it infinite? No doubt. Every non-regular has to be infinite. And is it regular? No. In case if you have one more option non-regular, choose that. But now infinite is fine, but we also know it is non-regular. And definitely it is infinite. Every non-regular is here over sigma is infinite set. Okay. Come to the point. Complement is closed for which languages or which domain, you can say? Is it set of finite languages or domain has the finite languages? Now finite complement is infinite. That means you're not in the domain, you're going outside the domain. Infinite language, when you do the complement, result may be infinite or it can go outside the domain too. If you take sigma star is infinite, sigma star is infinite. If you do the complement, you'll get empty set. Empty set is a finite set. It goes outside the domain. Regular complement is definitely regular, so it is closed. So look at the property of the complement. If L is a finite O, this is called as clinic closure. What is the clinic closure? When somebody is talking about L star, which is same as L power 0 union L power 1 union L power 2 union and so on, this is called as clinic star or clinic closure operation. Okay, so you can repeat 0 number of times, you can repeat 1 time or you can repeat 2 times, but do the union of all these choices to get the L star. Okay, now if L is a finite set, what is L star? There are many choices I'm talking about. I'm just talking about, let's say, if some L I'm taking pi, then what happens to L star? That's a pi star when you do it, which is nothing but epsilon, right? You get only epsilon. Is it finite or infinite? Finite. So clinic closure of finite, this is a finite. Clinic closure of finite, you may get finite. In case other than, empty set and epsilon, you can also take epsilon, but if you take epsilon again, you will get epsilon. I'm just taking some other language. Let me take A. A is also finite, right? Then if you do L star, you will get A star. You will get A star. So this is not finite, this is infinite. So what I'm trying to conclude here, when L is finite, L star may be finite, may be infinite. That means you can't choose always finite, you can't choose always infinite, but can I choose regular? Can I choose regular? Yes, because see, when you say finite, it is already regular. Clinic closure of a regular is definitely regular, because every regular you can write regular expression, put whole star, you get another regular expression. So this is true. It is always regular. As you know, the clinic star is one of the operator in the regular expression. So every L, that means every finite set, you can write a regular expression. For that, just put whole star, you get another expression. So that definitely generates regular language. Next, if L is infinite, then clinic closure of infinite. See, I'll just tell you why finite set clinic closure is not always infinite, because of two reasons only. One is the empty language, another one is a language with epsilon. See, if L is equal to empty, L is equal to, let's say, epsilon, under this situation only, L star you get epsilon here, here also L star you get epsilon. Except this two, you take any other finite set, its clinic closure you will get infinite. That means if anybody in the question asks, other than the empty set or other than the zero length string language, the language which has only zero length or language is empty, except these two cases, you take any finite language in the world, do the clinic closure, you will get infinite. Because of these two reasons only, clinic closure of a finite language we are getting need not be finite, need not be infinite, because of these two cases. Okay, fine. Anyhow, clinic closure is not closed for finite languages. Okay, not closed for, because of, see that reason, only these two languages you are getting finite back, but remaining all languages you go outside the domain. Now infinite is very simple. L is already infinite. L is already infinite. Take this infinite language, do the clinic closure, you always get infinite without any doubt. As we see, even finite set was almost giving infinite when we do the clinic closure, except two situations. But when you take infinite set, in that one string would be sufficient to generate the infiniteness by repeatedly. Okay, so it's always infinite. It's always finite is wrong and infinite is always correct, but regular, that depends on what infinite you take. If you take this infinite is regular, then clinic closure of regular you will get regular. In case if you take this infinite is non-regular, then we should be careful. A non-regular clinic closure, anything could be possible. Okay, We can't guarantee regular. Okay, I'm going to give some examples for you to do the homework, right? If L is regular, then L star, I already told it is regular, but is it finite or infinite? That depends on what regular you take. If you take regular language is empty language, then you will get finite as after clinic closure. But if you take other than empty language, other than epsilon, you get you take any regular, you will get infinite. So finite possible, infinite possible. So that's why we don't choose always. But regular is correct answer. I'm going to give some homework examples. So this is the homework for you, and keep working on some examples to get the conclusion. Not easy, I know, that's why I'm giving homework. If L is non-regular, there are many options you have in the world. Infinite non-regular languages are there. In that, is there any non-regular after its clinic closure, you get finite? Is that possible? See, I'm just writing here non-regular. Is it already infinite? Yes. When you do it, will you get non-regular again? That I can't say right now, but you will definitely get always infinite. But what about it? Regular. See, non-regular when we check, let's take one example, a power n, b power n, whole star. Okay, when you take its whole star, definitely will get its another non-regular. This a power n, b power n is non-regular. When you do the clinic closure, you get a non-regular. So this regular is also wrong. So my question is here, think about, find any one example if you know non-regular, its clinic closure, then any one example you will get a regular. Just think about it. You have any non-regular, by repeating its clinic closure, by repeating it, you get any regular language. Okay, I'm giving a hint. I'm almost giving an answer for you, but I want you to work on this, as many times even I don't get an example sometimes if I don't think properly. Here, non-regular means just take a power n, b power n. We know if you do its clinic closure, definitely you will get non-regular. I do one thing, union a comma b. If I do this, then do clinic closure, you'll get, because of these two strings, a plus b whole star comes out. So that's what I'm talking about. When you take this is L, and we know it is non-regular, but if you do L star, you will get a plus b whole star. But this is regular. Means sometimes regular possible. Because sometimes what happens, you may assume non-regular clinic closure is non-regular. That's wrong. What we know, it is infinite, no doubt. It is infinite, no doubt, but maybe regular, maybe non-regular. That's that answer. And I'm also giving homework to work more on this question, right? It is infinite, but it may be regular or non-regular. That depends on what language you take as a non-regular. So we have many choices that when you take L is a power n, b power n, its clinic closure is non-regular. When you take L as this one, then its clinic closure is a plus b whole star. Because of this a or b choices, when you put whole star, this two enough to produce every string in the sigma star. Okay, very nice example. And do the homework. Even though I have given answer, don't blindly take it, and keep working on the examples that I've given here. Spend some time to get clear idea. What about clinic closure now? We have seen examples for various domains. Clinic closure is closed for which languages? Finite, right? Clinic closure of finite can be infinite. We have to look for the closed. Infinite language, you take clinic closure, you will get again infinite. That's true. Regular language, apply the clinic closure, you will always get regular. Okay, but non-regular, when you take apply the clinic closure, you may get regular or non-regular, depends on what non-regular you take. Fine. Okay, it's again, I think there's a time to work on your own. Like I have explained a lot of converse statements, right, for union, intersection, concatenation. So these are the homework questions for you. In case you have understood till now all the operations, now you should work on this clinic closure, and please post your answers for this converse statements. If L star is finite, then what is L? L has to be finite. I'm giving the answer, no doubt about it. So please take it as homework. I'm Also asking what are the right answers you have here. It could be possible, if it is L is the finite, then you can call L is the regular too. Okay, there's no doubt about it. But you can say it's never be infinite. I'm leaving for you, but I'm also discussing what is the right answer for it. When L star is a finite, there's no doubt L has to be finite. L has to be finite. But when L star is infinite, then L could be anything. So another one I'm discussing, that's it, but it is homework for you. When L star is infinite, then L may be finite or L may be infinite. You do not know about it, right? It's possible to be two choices. And when L star is infinite, L may be regular or may be non-regular. So in my words, the answer already there, but you should think of what is the right answer for this. If L star is regular, it's a P by Q. It's a gate question too, and really very interesting for you. In case if you are aware of A power prime, if you know this, its whole star is actually regular. But this A prime is not regular. So one of the best example you have in the gate so far, if L star is regular, L may be regular, may be not regular. It depends on what L is given, what is L star. Okay, so it's a very important point. Do not assume if L star is regular, L is regular. Don't assume that way. L may be non-regular, may be regular in some examples. Okay, so I can say that if L star is regular, L may be finite. You do not know. L may be infinite, or L may be regular, may be non-regular. So don't choose these three options at all. Go for none of this, but have a clear idea why I have given this example. This example is you may not get this logic, or you may not get this example to interpret with this statement. That's why I have given here. If you don't know this example, this kind of question conclusion would be little, it takes time little bit. If L star is non-regular, L star is non-regular, and what is L? Can you assume finite? If it is finite star is never be non-regular, right? You know that regular star is definitely regular. So L never be finite. L never be finite. In case L is a finite, you will never get finite star is non-regular. So it's very clear, L never be finite. When is given that L star is non-regular. L star is non-regular means L impossible to be finite. L is infinite. See, already L never be finite means it has to be infinite. There is no doubt. But which infinite? That's I'm not concluding. But we know it is infinite, no doubt, because only the infinite languages, their clean closure possible to be non-regular. Okay, when somebody is saying L star is non-regular, clearly L is infinite. But which infinite? Is it regular or non-regular? That is, if in case L is regular, clean closure of regular is regular, that means L has to be non-regular. So this statement is also wrong. So we have two statements. L is definitely infinite. Not only infinite, it has to be non-regular only. In this situation only you get. But don't say this way, sir, L is non-regular, then clean closure is non-regular. I am not talking about this statement. This side may be false. When L is non-regular, L star may or may not be non-regular. I'm saying again, when we are talking about the statements from one to other side, don't assume converse side. Converse side may be false. Here we already know that if L is non-regular, L star need not be non-regular. I have proven that statement. But here L star is non-regular means L has to be non-regular. No doubt about it. Okay. This statement also can be concluded from other ways. But think about here. Can I say something about regulars? Can I say L star is regular implies L is regular? Compare these two statements. L star is regular. You cannot conclude L is regular. L need not be regular. We already have these things. So clean closure is somewhat different from complement. Complement was straight away, like same algorithm is applied from L to L complement and L complement to L. But clean closure is not that. somewhat different from complement. Complement is, L is L is regular, L complement is regular. L complement is regular, then L is regular. If L is non-regular, L complement is non-regular. So complement was so easy to speak, but clinic closure, you require some knowledge to apply to know what is L when L star is non-regular. L is definitely going to be non-regular. The reason is, if anybody says L is regular, then L star never be non-regular. Because understand, how can you say L is regular? If you are saying that, how will you prove L star is non-regular? That is already given to you, right? Understand, only we got to know that L is definitely infinite or non-regular. Okay, think much. That's about clinic closure, and just your job is make a table, clinic closure, what domains are closed, what domains are not closed. Okay, so I'm not making the table, but you can make a table now beautifully, like union, intersection, concatenation, set difference, complement, and clinic closure. All of them you can make a table to see which domains are closed or not closed. Okay, that is also homework for you to have a short notes, and that will help you to revise regularly. Okay, if L is a finite set, then what is a subset of L? L is given as a finite set. What is a subset operation? Subset means take any number of strings from the given language. Now let me take this finite set. When I am taking the subsets of this L, is it possible to be infinite set? If I am going to take the subsets for this, every subset you take, every itself is a subset, that is the maximum cardinality, right? Every subset is definitely a finite set. Yes or no? Is there any possibility? I have only finite number of strings here. How can I pull infinite number of strings from this as a subset? Not possible, right? So here, if L is a finite, then definitely every subset from this finite set is gonna be finite set back. So can I say that subset? Then not just subset, you can say every subset. Every subset of L is definitely finite. That's why subset operation is closed. And when I am saying finite, how can you say infinite? But when I say finite, you can say regular, because I'm speaking only one direction. Only one direction. If I'm saying I'm in Delhi, then obviously I'm in India. Somehow the relation holds, because every finite is what? Regular. What about infinite set? I have infinite set. Then every subset of this infinite set, every subset, I'm just saying that every subset. I'm not writing every means, I'm talking about every only by default. Every subset of this infinite set, can you guarantee it's again infinite? No, right? It may be empty set. Empty set is a subset for everybody in the world, you know that. Empty set is by default subset for every set in the world. Now, for infinite set, you have finite sets as a subset, you have infinite sets as a subset, you have regular sets as a subset, but not always, sometimes only. Okay, so all these statements are wrong. If I take infinite set, let's say a power n, b power n, here just I can take 1 ab, this is a finite. If I take itself, it's infinite. If you want to take this finite, is already regular, it's already non-regular. You don't need to take other examples to prove it, right? That's enough. Why all these three statements are wrong? Because you can't say always finite, because there are infinite subsets. Infinite set as a subset to this given set. Okay. Similarly, regular also failed. If L is the regular, then subset of L is always regular. Let me take a very simple example, A star, B star. Do you guarantee every subset of this L, every subset of this L is also regular? No. Look at A power n, B power n is actually inside only. This language is the subset of this language only, but this language is non-regular. Are you getting my point? Right, this is the best example I can provide you right now. That is, subset of a regular need not be regular. That's right. But is it finite always? No, this is infinite, right? So you can say that it's not always. Is it always infinite? So every subset, I'm giving only one example, but there are various subsets here. Empty set is also subset of L, right? There are infinite subsets possible because language is infinite. Now, don't say always infinite wrong. Don't say always regular. Here, even though itself you have, of course, empty language already regular, right? There are so many subsets are there. This is also regular, but not all the subsets are regular. Only some subsets are regular. So what you can conclude, the subset of a regular need not be regular. That's why subset operation is one of the important point for the regular languages. It is not closed for regular languages. Subset operation is not closed for regular languages. Okay, subset operation is not closed for regular languages. Non-regular set. Okay, now you have some non-regular. I'm trying to take the subsets of it. Do you get always finite? See, non-regular itself is infinite and itself is a subset. Then how can I guarantee always finite? Wrong. Okay, next, is that guaranteed every subset I take it is infinite? You know, empty set by default is a subset to every language in the world. Then empty set is not infinite set. Well, and I'm talking about non-regular. Non-regular itself is a subset, right? That means I have a non-regular subset, but you are saying every subset is a regular. Wrong. Can I say every subset is a non-regular? That is also wrong. So, subset of a non-regular may be regular, may be finite, may be infinite, may be non-regular. All the possibilities you will have. If L is finite, now we are going for the reversal operation. What is a reversal? Suppose you have the language, let's say AB comma AA BA. Then what is its reversal if you do? I'm just doing reversal. So you will get L power reversal, which is every string will be reversed, like BA, and do the reverse ABAA. Every string will be reversed to get the language reversal. Fine. This is the reversal definition. Then L is the finite. Finite means how many strings are there? Finite number of strings. When you do the reversal, again you will get the same number of strings, right? You will get the same number of strings, but every string will be reversed. Can I say reversal of a finite language? A reversal of a finite language, is it always reversal? Yes, it is reversal. It is always a finite. Reversal of a finite language is always finite at any cost. That's true. Can you say infinite? Already I have given finite. How can I say infinite? Purely opposite statements. And every finite is regular. So you can choose regular. That's all we have now. Hence, reversal operation is closed for the domain which has the finite languages. Okay. What about infinite? If L is infinite, apply the reversal, every string will be reversed. Again, you will get infinite language, right? So infinite set you take, apply the reversal concept, you will definitely get infinite. As you know, after doing the reversal, number of strings will not change. Only the string direction changes. Previously, you will read from left to right. Now, you will read from right to left. That will be the new string. So it's infinite, but is it regular or not? That depends on what infinite you have taken. What infinite you have taken. If you have taken that infinite is regular, then result will be regular. If this infinite is non-regular, non-regular reversal you will get non-regular. So anyhow, this is, you can't choose because you don't know which infinite you are talking about. I have not given L is regular but infinite. In case if I give that, then result definitely infinite and regular you get it. Okay. Next, if L is regular, then reversal of L is also regular without any doubt. Will have algorithm. You have an algorithm like if L is having, let's say, any finite automata, what do? Do some changes to get the new finite automata that accepts reversal of L. What changes you do is, if you have final and initial, and always guarantee you have one initial and one final using epsilon moves. So ensure you have one final with the help of epsilon moves, epsilon transitions. How do you ensure? If there are 4 finals, create a new final, give epsilon moves and make this existing finals to non-finals. So if you have 10 finals, you have to make only one final. Then what you are going to do, you are going to interchange initial and final. One initial, one final is the concept. Initial, make it as a final, and final, you make it as initial. Interchange, that's it. And every edge that you see in the DFA or finite automata, just reverse it. All transitions, you see all edges, the transitions, or you can say edges, better. All edges, just do the reverse. Change the direction, reverse the direction, reverse all edge directions. That's all. When you do it, you will get a new finite automata, modified finite automata, that will definitely accept L reversal. Anyhow, this concept is required only to explain somebody or to understand. I hope if you are already practiced, you know this concept. Then reversal of a regular is regular. Is that clear? Why I'm writing this algorithm? Because why I'm saying this reversal of a regular is regular, because I don't worry about which regular. I always have a proof for that. Any regular, we have a finite automata, and you can modify this finite automata to accept the reversal of that regular. Fine. And finite we don't know, infinite we don't know. Clear? If L is non-regular, then reversal of that non-regular. In case you assume reversal of a non-regular is regular, then what happens with reversal? You will get the same language, right? Okay, just assume that L you have, do the reverse, you will get L power reverse. If you do again, you should get the same, right? If any one of them is regular, other has to be regular. If any one of them is non-regular, other has to be non-regular. Because if any one of them is regular, we have an algorithm to do the reversal, right? To understand what I'm trying to say, it's just similar to the complement concept. Like it's not just if then. You can say L is non-regular if and only if reversal is non-regular. You can use that word too. So I can conclude now. L, you can't say about finite. Can I say infinite? Because every non-regular is infinite. We know that. But choose appropriately. I'm not talking about every infinite in the world. I'm talking about every non-regular that we have taken. And regular we can't choose. But we are very clear, reversal of L is a non-regular. In case if you have any example that you are not able to get it, in case if I misjudge the statement, then please discuss below this video. I'm happy to help you. Where do you go wrong? Or sometimes, getting the right examples very important for every statement. If you have a lot of examples, please discuss, is this example right or wrong for this statement? We will conclude that how to approach it. Which of the following is closed for finite languages? Very interesting. Okay, these things you have to work on. Finite union, finite intersection, finite concatenation. These are very interesting. And I'm just going to give the answers for these operations. Finite languages is your domain. But operation is not just union. It's a finite union. It means the number of inputs you take finite. It means I have 100 finite languages. After doing the union, will I get a finite? So how many languages you are taking? Not 2 languages. Normally union is what? Binary operation, right? But this finite union is not binary. You can take any. Like L1 union, L2 union, L3 union. You can take k number of languages. So now the finite union means that union is applied many times, but finite times. So this is the main difference. Union is binary, but finite union is k-array, where you have the k inputs to here. Okay, so understand this. Now I have finite number of finite languages. That is the meaning. Finite number of finite languages. I'm applying the union of all of this. Then that operation is called as finite union. Now tell me, union of 2 languages, 2 finite languages. Already we know it's a finite. Now apply 100 times. 100 languages I have. 100 languages I have. Union of this 100 languages, what happens? 100 finite languages, union is again finite only, right? Because I am going to do the union finite times only. So finite union definitely closed. And what about intersection? We already know finite intersection finite is finite. Now this intersection we are going to apply for 100 languages or 1000 languages, but finite number of finite languages only. Again, it's closed. Concatenation, we know finite dot finite is finite. Now we do 100 times finite dot finite dot finite dot finite dot. Maybe you do 100 times, you get finite back. This all three are closed. Now let's try for the infinite languages. Now finite union means finite number of infinite languages, like I1 union I2, infinite languages. How many infinite languages you take? Only finite times. Now I can't take any, I can take 100 or 1000. Specify the constant or specify the how many infinite languages. Count you need to specify, but any is fine, but should be specified 100 or 1000, but you can't say infinite. Unknown you can't say. Fine. Finite union now. Infinite union infinite is definitely infinite. Yes or no? Now this infinite languages you are taking the union finite times. That's what, taking finite times. The result definitely infinite. Right? So you are getting the result in the same domain. So finite union is closed. Single union is closed, definitely finite union. Finite intersection. You already know infinite intersection infinite. Infinite intersection infinite. This is only not guaranteed to be infinite. Now how can I guarantee when I apply k times I will get infinite? We don't know. So it's not closed. Concatenation. Infinite dot infinite. Are you aware of this? Infinite language followed by infinite language. When you do the concatenation, you get again infinite. You get again infinite. So similarly, you are applying k times. That k is what? Finite. That's finite number of infinite languages concatenation. Here you will get again infinite set. It is closed. Closed. Very interesting operations you have here. Which of the following is closed for regular languages? Okay, you know, very simple this. When you talk about this finite union, finite intersection, finite concatenation, finite difference, finite subset, all are closed for regular languages. The problem happens with the infinite union, infinite intersection. Okay, you can assume that single union is closed for regulars, finite union is also. Single intersection closed for regular, so finite intersection. Single concatenation, that means for two regular languages, when you apply concatenation, it's already closed. So finite times you apply concatenation, you get the same. Okay. With this, we have a conclusion on the closure properties of regular languages. But believe me, we have learned a lot, but there is a lot to learn about the closure properties too. But exam point of view, some things are very important. What? You don't need much examples for many operations. Like if you talk about regular languages, just remember a few points. Regular languages, what are closed, what are not closed is very important to know. Mainly, you should remember like the subset operation. Not only this, when you talk about infinite union, infinite intersection, infinite difference, and infinite concatenation, infinite subset, these things are not closed for regular languages. And remaining, you may study many things, like if you are talking about union, single union, intersection, set difference, concatenation, what else? Reversal. Okay, you have here, let me write L1 minus L2. You also have a complement. L1 intersection L2, L1 union L2. Assume L1, L2 are talking about regular languages. Now L reversal, L complement. Likewise, you have lot of, you know, f of L, the substitution of L, homomorphism of L, and prefix of L. Any operation you take, they're all closed here. They're all closed. There are many operations you have in this closure properties. Here, instead of remembering what are closed, just remember what are not closed. Except this, remaining all that you see in closure properties all are closed. So subset, infinite followed by any name that you see are not closed for the regular languages. This is how you can easily remember the closure properties for regular languages. But you should know the definition of each and every operation that you see in this topic. Of course, you can't learn 100,000, right? You can learn up to 20 to 30 operations. As I said, some of the list I have given here, like prefix, suffix, substring of the languages, and also you have many other operations like half of L, one third of L. At least you know the definition of them, and that would be sufficient. Overall, here we have learned some of the important concepts. Like I told, I'm just making the table. I'm giving the homework for you to fill this table. Like you have learned union, you have learned intersection, and this will help you a lot and to solve many questions in coming gate exams, and you can also solve the PYQs. Complement and difference, the difference. We've also learned a reversal, and what I have given here, a very important list I have explained in this video, subset. And what is your job here is find out these operations are closed for finite languages or not. The first job. And once you do this, do one by one, because don't mix all at a time, right? So work on finite languages once, then go for infinite languages. For finite infinite, I think these two columns would be sufficient, but for regular only you should learn very big table, regular sets. So make this table complete on your own by looking at this video, so that you will be having all the important points required for the exam, all the important points. But especially for this column, you have the very big table, but you don't need to remember all. I told you which are not closed for regular. So in that table, just remember subset, not closed, and infinite followed by any name that you see, not closed for regular sets. That's how you can remember very easily. But make the table clearly for finite languages, what are closed, what are not closed, and infinite languages, which operations are closed or not. Similarly, you make the table, and with this we have completed the successfully this closure properties for regulars and non-regulars. Okay, and I'm very thankful for watching this video. In case if you have the doubts, please discuss with us by posting your comment below this video. We are really happy to help you, and all the best for your exam, and see you in the next lecture 4. Thank you so much. Bye bye. Take care.